Hi, hello, குட்டி பசங்களா எல்லாருமே ஹாப்பியா சேஃபா இருக்குன்னு நினைக்கிறேன். So yes, Naveen, then Murugan, then who's that? Mughal Kriba, okay? So if I'm pronouncing something wrong, you should correct me, okay? Okay, because நான் எப்பவுமே சொல்றது மாதிரி என் தமிழ் வந்து அவ்வளோ நல்லா இல்லை, நீங்க தான் கரெக்ட் பண்ணணும். ஓகே, ஐ வில் டீச் ஃபிசிக்ஸ் அண்ட் யூ ஷுட் டீச் தமிழ். இந்த கிளாஸ் முடியறதுக்கு அப்புறம் நான் நல்லா தமிழ் பேசணும், அதுதான் டீல். ஓகே, இந்த கிளாஸ் முடியறதுக்கு ஐ மீன் அந்த டைம்ல நீங்க வந்து பிசிக்ஸும் இந்த சாப்டரை ரொம்ப நல்லா படிக்க போறேன். ஓகே, ஹாய் Zoro. Yes, Naveen, definitely we will be having revision as well. ஸோ இன்னைக்கு வந்து நான் சொல்றேன் எப்படிதான் இந்த கிளாஸ் போக போறது. நான் உங்களுக்கு ஒரு ஐடியா, ஐ வில் கிவ் யூ an idea about. Okay, don't ask me how many hours. Till we have the energy, we will continue. Yes, derivation இருக்கு, எல்லாமே இருக்கு. You don't have to worry about anything. Okay, so நாம இன்னைக்கு பார்க்க போறது electric charges and fields. Okay, அது முடிஞ்சதுக்கு அப்புறம் டைம் இருந்தா நமக்கு வந்து செகண்ட் சாப்டர் கூட கண்டினியூ பண்ணலாம். Okay, and also yes, very good. Okay, so இந்த சாப்டரோட ஸ்பெஷாலிட்டி என்னன்னா, டோட்டல் எலக்ட்ரோஸ்டாட்டிக்ஸ்ல இருந்து நம்ம PYQ பார்க்கும்போது ஆல்மோஸ்ட் 10-12 மார்க்ஸுக்கு கொஸ்டின் வரும். CBSE போர்டுக்கு 12 மார்க்ஸ். Okay, that is not it's a very big thing, correct? So இன்னைக்கு நாம வந்து இந்த 12 marks we will make sure that we will get it, all the questions which is coming from this chapter, right? So இன்னைக்கு வந்து பாசிட்டிவா நமக்கு கிளாஸ் ஸ்டார்ட் பண்ணனும். Yes, including second also. Yeah, yes, of course we will do it. And also இன்னைக்கு வந்து ரொம்ப ஸ்பெஷலான டே. Can you guess it? Anybody, can you guess it? Why it is so special for our channel? Can you guess it on the comment box, please? We will do it for sure. What is special? What's the thing which is striking on the channel? Yes, we have reached 20k. Yes, in this 20k, if we have, this channel has reached 20k, it is only because of you, only because of your support, and definitely I should specify the care about us. That is also very, we should say a lot of thanks to you people. And of course, in the 20k, we have reached 20k. அதனால உங்களுக்கு ஒரு சர்ப்ரைஸ் இருக்கு February 6th. ஓகே, ஸோ எல்லாருமே அந்த லைவ் செஷன் அட்டென்ட் பண்ணணும். டோன்ட் ஃபர்கெட் February 6th தான் செஷன். Okay, so in the 20k, we are going to celebrate with something special. So let's see. Okay, fine. So as I mentioned, in the chapter one, almost 12 marks, we can just score 12 marks from this chapter. And also இன்னைக்கு வந்து நம்ம as I mentioned, I will tell you how the class will go. நம்ம வந்து revision, okay, we will do revision. Also we will do some PYQs as well. Okay, because why we are doing PYQs, we should get the pattern of the questions. Okay, இந்த சாப்டர்ல இருந்து இந்த டாபிக்ல இருந்து இந்த மாதிரி questions தான் வர. Okay, then we will be work on that. Ma'am, romba bayama irukku. No worries. As I mentioned, you have to be very smart. We don't have much days. Innum konjam days mattum da irukku. And in the konjam days, smart work pannitena, the boards, it is not going to be a headache for us. We will crack it. As I mentioned, those who are coming, please like the session, because later also you can watch it. Also subscribe the channels. As I mentioned, lots and lots of surprises, special things are coming soon. So subscribe now. Okay, so let us do this. Sure, you can. So now we will be starting with the electric charges and fields, high weightage chapter. And in the chapter la the first topic is nothing but electric charge. So electric charge na enna? It is nothing but it's a property of a matter, right? It is a property of matter. And also it is always it is associated with the, okay, one second. Okay, we are talking about electric charge and in the charge வந்து always mass, it will be associated with mass. If mass இருந்தா தான், இந்த mass இருந்தா தான் charge இருக்கும். Mass இல்லைன்னா charge இல்லை. That is what we should understand. If there is a mass, there is a charge. If there is no mass, no charge. Okay? It is always associated with, the mass. Okay? Yes, very good, very good, very good, very good, Naveen. Okay? So now we know the charges. We have two types of charges. What are the two types of charges? We have positive charge. Okay? We have this positive charge as well as negative charge. So positive charge na enna, negative charge na enna? Physics la vanda positive negative enna adha nama ipo padikka poren. Positive na, like in real life also, when we are avoiding or when we are releasing the negativity, we will become more positive. Correct? Okay, whenever we are just remove all the negativity, we will become positive. Exactly the similar way, when any object, any body is just losing the electrons. Okay, it is losing the electrons. Okay, yes, very good, very good, very good, guys. You are on the track. Okay, when we are releasing electrons now, negative charges, negativity. When we remove negativity, we will become more positive. So I can say that less electrons. So if I am releasing one electron, now one positive. Okay. Whenever we are attending Lerin Mam session, we are releasing electrons. Thank you so much, Naveen. Thank you. Okay, so less number of electrons, which means on the body positive. Okay, and more number of negativity, now we become negative. So we can say that more number of electrons, which means that is representing negative charged body. Okay, so positive charged body na enna, less number of electrons. Okay, negative na enna, more number of electrons. Understood, everybody? Understood? Because this is the base part. And also now my question is, now you understood what is positive, what is negative. So in the positive body, I have a positive body, I have a negative body. Okay, so or let's say we are taking two identical bodies. Okay, we have two identical bodies. In the body 2-3 electrons remove பண்ணிருக்கு. ஆனா இந்த body அந்த 2-3 electron gain பண்ணிருக்கு. So எதுக்கு mass, I mean which one is having more mass? You should tell me. We have two bodies A and B. Okay, we have two bodies A and B. This is removing electrons and this one is gaining electrons. So idhila A or B, which one is having more mass? Definitely, very good, Naveen. Naveen is perfect. Okay, and yes, of course, Mukul Kriba, very good, very good, very good, very good. Yes, of course, Murugan, I will do all the chapters, and also we will do PYQ sessions, and also we will do separate sessions for derivations. Everything we will do. Okay, and who's this? Udaya Medico. Okay, fine. Very good, very good, very good. Okay, so we know that this electron is having mass. So definitely when I'm releasing one electron, my mass will reduce. When I'm gaining electrons, what will happen? Your mass will increase. Okay, so for positively charged bodies, we can just say in terms of mass, the mass will reduce when it is releasing the electrons. When it is gaining, the mass will increase. So idum important. Next one, so now we know about electric charge. Next we are going to talk about the properties of charge. Of course we know like charges repel, and unlike charges, what will happen with unlike charges? It will attract, which means if we have two positively charged bodies, it will repel each other. If we have two, one positive, another negative, it will get attract. Okay, then we should know that the quantization of charge. What is quantization of charge? What is quantization? It is something like a multiplication table madri. 5 table. Okay, adla 12 number. I mean, it won't be there, right? It will be the multiple of 5 only. It cannot be the multiple of something else. The the multiple table of something will be something like yes, 5 into 1, 5 into 2. It is the multiple of 5. So, அந்த மாதிரி chargeக்கும் quantization இருக்கு. The total charge on a body will be always NE. What is this N? What is this E? Yes, very good, very good, very good, very good. Q is equal to NE. And E is the charge of one electron. What is that? 1.6 into 10 to the power minus 19 Coulomb. Okay? So, we can say that quantization of charge means it will be the total charge on a body always will be the multiple of E. What is E? Charge of electron. Okay. So, we can say this will be 1.6 into 10 to the power minus 90 Coulomb. Everybody understood? Everybody understood? So, this is what the quantization. Next one is, of course, we are going to talk about the conservation of charge. What is that name itself suggests something. What is that conservation of charge? What is conservation of charge? We can say that if we have a body, okay, always in the universe the charge will be conserved. Conserved na enna? It can be neither be created nor be destroyed. Okay. So, conservation nama idukapra methods of charging padikka pora. Adila konjam detail na solren. Okay. So, now we have the conservation of charge. Conservation of charge. And definitely very easy thing is that this charge is a scalar quantity, right? The charge is a scalar quantity. So definitely we can just add like very simply, like how we are just adding 1, 2, 3 numbers. Exactly the similar way we can use the additive property. If we have Q1 charge here, Q2 charge here, Q3 charge here, then we can say the total charge in that body will be Q1 plus Q2 plus Q3. Okay. Now let us say, now I am saying the charges are minus Q1, minus Q2 and Q3. Then what is going to be the total charge? Minus Q1 plus minus Q2 plus Q3. So now we can say this is nothing but the additivity of charges. Okay. So the properties, when we are talking about the properties, we should say the additivity property as well as conservation of charge and quantization of charge. And idhila the quantization of charge the numericals, we can expect the numericals also. Understood? Okay. Yes, of course we will deal with the questions also, you don't have to worry. Okay. So those who are coming new, please don't forget to like, also subscribe. As I mentioned, we have a lots of surprises. Okay. Rotational motion and center of mass I will be doing in the morning session backlog series. So you don't have to worry. This is for the CBSE Class 12. So definitely that I will do. And here also we will be going with the 12th boards. Got it? Everybody understood? Any confusions, anything? Yes. So now we got few things. We understood the properties and everything. And what is the unit of charge? We already mentioned that the unit of charge is nothing but C. Or otherwise we can also say Coulomb, or we can also say that ampere second, because in current electricity we will study I is equal to Q by T. So Q I into T. So we can say that the unit of I is ampere and time is second. So ampere second, or otherwise usually we will be going for Coulomb. Okay. And the dimension. What is the dimension? What is the dimension? We can either say AT or we can say IT. This is going to be the dimension. Okay. And we have just studied that also. we will be calling it as ESU, electrostatic coulomb. That is what the unit, and that value 1 coulomb which is equal to 3 into 10 to the power 9 ESU. This is what the CGS unit. Understood everyone? Next one, we are going for the methods of charging. Okay, methods of charging. So in the methods of charging, three types. What are the three types? What are the three types? Yes. Tell me. Yes, very good. We have friction. Okay, we have friction. We have conduction, and we have induction. So what is friction, what is conduction, what is induction? That is what we are going to discuss now. Friction, we will take two bodies. Okay, after we will scrub it, or let's say after we will just do like this. So we know that whenever we are doing with our hands also, what exactly happening? Yes, heat is produced, which means the electrons will be getting some energy, correct? Electrons are getting some energy. Okay, when we rub with our hands, we can experience the heat. So whenever we are taking two bodies and we rub each other, then the heat will be produced, and this heat energy will be used by the electrons to escape. Okay, so the only condition for friction is the two bodies, whichever you are taking, the work function of the bodies should be different. It cannot be same. Okay, work function. What is work function? What is work function? The minimum energy required, right? The minimum energy required for an electron to escape. So that energy must be different. Otherwise, what will happen? Both will be getting the energy and this transfer won't happen. Okay, now we are moving on to the conduction part. Okay, conduction. What is conduction? Definitely we know that in friction also there is a direct contact is required. In conduction also the direct contact is necessary. Okay, direct contact is necessary. What is the condition? What is the condition for this? Okay, why it is not working? Something is happening. Yeah, okay. Direct contact is required. Also, whatever be the bodies we are taking, the potential should be different. Understood? The potential should be different. Potential will be different, which means I am taking a positively charged body and a neutral body. Neutral body na is equal amount of positive and negative charges, right? Okay, it is balanced. So if I'm taking a positive charge as well as a neutral body, comparing with the potential, okay, the electrons will always move from the lower to the higher. So what will happen? The transfer will happen. If these two bodies are having the same potential, this conduction won't work. So the potential should be different. Potential should be different. That's another important one. Okay, conduction la if we are taking two bodies, the two bodies should have different potential. Let's say, for example, we are taking negatively charged body and a positively charged body. So now electrons will travel from lower potential, which is the negatively charged body, to the positively charged body. Okay, understood? Got it? So now we will be, I will reduce the speed, no worries. Okay, so now we will be going for the induction. So we understood what is friction. When we rub two bodies, if the body is having different work function, the electrons will be transferred. Second one, the conduction. Conduction na It is nothing but when we are taking two different bodies with different potential difference and we are just keeping them in contact, so definitely the electrons will transfer. Got it? Understood? Now we are going for the induction. The name itself says something. What is induction? Inducing something, right? So basically the major thing is no contact. No direct contact is required. Understood, everybody? Okay. So basically speaking, let us say if we have a charged body here. Okay, sorry, if we have a body over here, let us say there will be equal positive and negative charges. Now I will be come up with a positive charge. So when I'm taking a positive charge near to this, what will happen? Yes, in this body, all the negative charges will accumulate close to this body and equal number of positive charges will accumulate in the other side. So we can do one thing. Either we can just use one body and we can do this by earthing, which means I have this body. Now the segregation is done. If I'm doing earthing, what will happen? What is the advantage of earthing? Earth is an electron bank. What is the meaning of bank? What is the meaning of bank? Whenever we need money, we will go and we will collect it. Whenever we don't want money, we will go and deposit. So in this case, there is more positive charges this side. So electron bank will give enough number of electrons. So what will happen? There will be only this negative charges. So we will do earthing, then we will remove this, then we will be getting the negatively charged body. Okay. Otherwise we can just use two bodies like this and we can just do the same thing. We will be coming up with any charged body, okay, and the opposite charge will be induced at one end and induced will be at the another end. And then we will just remove it. Purinjada? Okay. So we will be getting a positively charged body as well as a negatively charged body. So the advantages, whenever we are doing this, we will be getting two bodies with equal number of charges. Fine, everybody? Okay. So this is what the thing. So we have friction, conduction and induction. So these are the three methods of charging. Okay. So now we should know all this value. Charge of an electron will be minus 1.6 into 10 to the power minus 19 and the proton 1.6 into 10 to the power minus 19. And also mass of electron, mass of proton, mass of neutron is also the same, 1.67 into 10 to the power minus 27. Most of the cases they won't be giving the values. So you should know all these values. If you haven't studied yet, please study. It is required. Okay, so we have studied about the electric charges. Electric charges the property of the basic property of a matter, and it is always associated with the mass, and we know that the like charges will repel, unlike charges will attract. Okay, and also we have studied the properties like additivity of charges, conservation of charges, as well as quantization of charge. And when we have discussed about conservation of charge, you can just see with this the methods of charging we have discussed. Let us say I'm starting with friction. So whenever we are going for the friction, somebody will be getting the positive charge, another one will be getting the equal negative charge, which means there is no new charges has been produced, there is no charges has been destroyed. Understood? Okay, so this is very simple. Also in induction, what is happening? Equal number of charges were produced. So there also in any of the methods, there is no new charges developed or there is no destroy. We are not destroying the charges. Always the charge, the number of charge will be constant. Okay. Next, we are going for the most important one, and from here onwards, we will be getting a lots of numericals as well. Okay, so what is that? It is nothing but the electrostatic force. What is electrostatic force? What is electrostatic force? When we, already we have discussed this thing. When we have two same polarity charges, two positive charges, it will repel. And what makes to repel? Some force is developing. And if there is a positive and negative charge, it will attract each other, right? And what makes them to do it? It is nothing but again a force between them. Understood? Okay, so we are going to talk about this force. Now let us just start from the definition. What is Coulomb's law? It is nothing but the electrostatic force between 2 point charges, between the 2 point charges, and the magnitude is proportional to the product of the two charges and inversely proportional to r square, which means the square of the distance between the two charges. Okay, so what we were discussing now? We were discussing about the Coulomb's law. What is Coulomb's law? Coulomb's law is nothing but it is the electrostatic force which is proportional to the product of the two charges, and it is inversely proportional to the square of the distance between them. Which means if we have two charges like this, Q1 and Q2, there is a separation between them, that is R. So now we can just say that the force will be proportional to Q1, Q2 divided by R square. Now we should have a constant to change the proportionality, and that is what we used to say K, Q1, Q2 by R square. And K is nothing but 1 by 4 pi epsilon naught, and this value is nothing but 9 into 10 to the power 9. Understood, everybody? Then we have the epsilon naught here. Okay, then we have the epsilon naught here. What is epsilon naught? Permittivity of the medium. Okay, permittivity of the medium. For in the case of air, okay, air or vacuum, what is the value? 8.85 into 10 to the power minus 15. So basically we should know all these values. The value of 1 by 4 pi epsilon naught is nothing but 9 into 10 to the power 9, and the value of epsilon naught is nothing but 8.85 into 10 to the power minus 12. Okay, and F is equal to K, Q1, Q2 divided by R square. Now the vector form. What is the vector form of this force between the two vectors? So here we can just say that when I'm talking about the force on the first charge due to the second charge, okay, so due to the second charge, so what is going to be that? Definitely this and this two will be having some force, and we know this is proportional to the product of the charges, and we know charge is a scalar quantity. Charge is a scalar quantity, so definitely we can just ignore the direction part. Now comes the position vector. So this time what will happen? This is going to be the direction. Okay, so we will be going for our vector. So whenever we are writing in the form of vector, or let's say if I'm just writing r cap, okay, I can just write r cap. Otherwise I can also replace this r cap with r vector, but then this will be r cube, because we know r vector is nothing but magnitude of r into the unit vector. So again there will be a magnitude, r is coming in the denominator, so we have to go for r cubed. Okay, this is actually for boards, CBSE boards. Okay, this is an exam oriented session. So Neet ku vandu separate classes irukku. We are just running in the morning session, so you can watch for Neet, you can just watch it, and for boards you can just listen this class. Okay, so now we got the values of this force, and also the force on the first charge due to the second one will be equal to magnitude wise it is going to be same, but the direction will be opposite. Why? Because when I'm talking about this is the first charge, this is the second charge, this is going to be the position vector. When I'm talking about the force on second charge on the first one, this is going to be the direction exactly in the opposite direction, so that won't work. Okay, so that is why we are just keeping the negative sign. It is just the opposite thing. So now you can just tell one thing. What is that? This is obeying Newton's third law. Okay, so now we can say that this Coulomb's law obeys Newton's third law. Also, it is proportional to 1 by r square. So we can say that it's also obey inverse square law. Okay. Now another one is this is the central force. Central force na? Yes, it is always from the center to the center. Okay, let's say if you have a body like this. Okay, now you cannot measure the length like this. You should always measure from the center to center. And always this force will act on the line joining the two charges. Okay, it is the nothing but the line joining two charges, and also it is depending upon the medium. It depends upon the medium. When we are keeping these two charges in another medium, then the force will definitely change. So it is also depending upon the medium. Understood, everybody? And this is the conservative force. Okay, it is a conservative force. So these are the properties of the this Coulomb's law. Also, we have to understand one thing. If this is not a point charge, if we are not taking the point charges, what is the meaning of point charge? What is the meaning of point charge? Yes, the dimension, or let's say the size of the particles is very less, much smaller comparing with the distance of separation. Okay, then we will be call it as point charge. So this is only valid for point charges. Okay, so we can just write this as the limitations. It is only valid for the point charges. Also it is if the charges are stationary. If the charges are stationary, then only we can apply this Coulomb's law. Everybody got what is Coulomb's law and everything? Any confusion so far for anybody? Please let me know. So now we understood the limitations also. It is only applicable for the point charges and the stationary charges. So next one is nothing but how this force changes with the medium. So we said that the force is nothing but 1 by 4 pi epsilon naught Q1 Q2 divided by R square. This is valid only for vacuum or air. Okay. Otherwise this will become, I'm just marking it as F dash, or let's say I'll be just write it as Fm, the force in some other medium. What is going to be that? 1 by 4 pi epsilon m, because permittivity in free space, or let's say in vacuum or in air, we will apply when the medium is air. If it is some other medium, we should write what is the value. If it is, we are keeping it in water or oil, then this value will change. So this equation becomes Q1 Q2 divided by R square. Now I'm just doing one thing. I'm just going for I'll go for F by Fm. Let us just do this. F by Fm. What will happen? We have this 1 by 4 pi epsilon naught Q1 Q2 divided by R square divided by 1 by 4 pi epsilon m Q1 Q2 divided by R square. So what will happen? 1 by 4 pi got Q1 Q2 by R square, Q1 Q2 by R square got cancelled. So we will be getting the permittivity in the medium divided by permittivity in free space. So we got another relation here. F by Fm is nothing but the permittivity in the medium divided by permittivity in vacuum. And this is nothing but the dielectric constant, or let's say we will be call it as relative permittivity. Okay, this is nothing but relative permittivity. The permittivity of any medium with respect to the permittivity with respect to the free space. Understood? I hope everybody got it. Yes, Joshua, it was started sharp at 5. Okay, you are almost 35 minutes late. Okay, so every day we will be having the boards class. So guys, you should be on time. Otherwise, the loss is for you guys only. Okay, now we are going for the principle of superposition. Okay. Principle of superposition. What is principle of superposition? We know that, okay, we know that definitely we will be having multiple charges in the universe, right? So we know if there is 2 charges, what is the force developed, we know. Okay, so now I am having, this is Q1, this is Q2, and this is Q3, right? So this distance is like, let's say, this 2 charges were separated by R13. This 2 charges were separated by R32, and this is nothing but R2. Okay, so now definitely between this Q1 and Q2 there will be a force developed. Between this Q2 and Q3 there will be a force developed, and between Q1 and Q3 there will be a force developed. Now if I'm just marking another charge over here, Q4, that will also contribute. Okay, so now if there are multiple charges, I just wanted to specifically know if I am keeping one more charge over here, due to all these charges, okay, due to all these charges, what is the net charge on this Q5? That is my question. Okay, we have 5 charges. I just wanted to know what is the charge on the 5th charge. Sorry, what is the net force on the 5th charge? So how we will be doing? We will go for the vector sum of all individual forces, which means in this case what I will do, I just wanted to know what is the net force on the 5th charge. Okay, all the rest of the 4 charges will exert some force on the 5th one. Correct. Okay, so let us say you people are 5 members are there in the team. Okay, let us say you people are going to do something. The 5th person doesn't want to come. So definitely you people will attract, or you people will call them, right? So the influence of the rest of the 4 charges will be there on the 5th one. So we will find, this is enough, this live is enough. Okay, but you should do more practice questions. I think I have I have planned for some 25-30 questions. That is not enough. Anyway, we will do the PYQ separate session for all the chapters one day. So you can just attend that session also. That is enough. No worries on it. Okay. Got it? Now I just wanted to know the fifth charge. What is the net force? So I'm just checking vector sum of all individual force, which means these are all vectors. So I'm thinking about Q1. Q1 will exert a force on Q5. So I'm just writing the force due to the first one on the fifth one. Vector. Plus, I'm thinking about the second charge. That will also exert some force. I can go for 5, 2. So like this way, if there are n number of charges, I will be going for adding individually. And it should be vector sum. You cannot, if let's say you are getting this as 5 and this as 2, you cannot simply say 5 plus 2. You should check the direction because force is a vector quantity. Understood? Yes, of course, this is enough. Please watch the session, okay? Now we have charges, equal charges. It is equally separated, okay? Equal distance. Then what we will do? We will just find each force and we will consider the direction and we will be working on it, okay? So this is what the principle of superposition. I hope everybody understood. So whenever you are getting any question based on finding the net force, first you guys have to do one thing, check the direction of the forces, okay, and mark the direction and then go for the vector sum. Take two forces and find it. That is the solution for it. So now we have studied a lot of things, okay. So now we know the methods and everything, and here we have studied the values as well. Yes. So now we have studied the Coulomb's law. What are the Coulomb's law? What is the Coulomb's law? It is nothing but the electrostatic force between 2 point charges separated by a distance r. The magnitude of this force will be proportional to the product of these two charges, and it will be inversely proportional to the square of the distance between them. Okay, and the mathematically we can represent 1 by 4 pi epsilon naught q1 q2 divided by r square. Then we have studied one thing. If it is in another medium, we will be rewrite this equation as 1 by 4 pi epsilon m, which means the permittivity of the medium q1 q2 divided by r square. And then we have discussed about all the properties, everything, and also at the end you will be getting the PDF of this class as well, so you can just refer the slides. Okay, that will also help you to complete your notes. And the properties of this force is nothing but it is a central force, it is a conservative force, also it is obeying Newton's third law, it obeys inverse square law. Also we have mentioned few more things. Then limitations of the Coulomb's law, we know these are all point charges, it is only applicable for point charges. Then we have discussed about the point charges, and what else we have discussed about limitation. Yes, of course, the distance of separation, this is only valid, I think I haven't mark that. Okay, if the distance of separation is less than 10 to the power minus 15, which means the nuclear radius. Okay, so if it is less than, then it is not valid. It is always supposed to be greater than this 10 to the power minus 15. Otherwise, nuclear force will also come. We know that nuclear force is much stronger, so we won't be applying this thing. Okay, so now let us do some questions. We are going for the questions now. So let's see what is. We have 2 point charges placed in a medium of dielectric constant 5. We have the K value or the relative permittivity value, that is nothing but 5. R at a distance R between them experience an electrostatic force F. Okay, so now we have 2 point charges. Okay, we have 2-point charges. Let's say I'm just putting it as Q1 and Q2. The distance of separation is R. And if, the medium is having a dielectric constant that is equal to 5. So what is going to be in vacuum? Okay. As I mentioned, for the Neet, we will be doing the sessions in the morning. So, Neet preparation, if you're looking for Neet preparation, morning session you can go for. And how we will be doing this question? We know, right? If I'm finding the force, in this case, it is in a medium which is having a dielectric constant 5. So, what is the equation we have mentioned? 1 by 4 pi epsilon m, right? Or otherwise we can just go for, I'll write it first, q1 q2 by r square. And we know this is nothing but epsilon naught epsilon r q1 q2 divided by r square. This is what f. Okay, and what is this value? Here I'm just writing k divided by 5, 1 by 4 pi epsilon naught. This is what? K. So k by 5 q1 q2 by r square is nothing but f. Now the same system we are going to introduce in vacuum, or let's say in air. What is going to be the force? F is this much. F we got. Now you should find what is going to be in air, or let's say in vacuum. Very simple question. Now you can do it. What is the equation for air? 1 by 4 pi epsilon naught q1 q2 by r square. No other values are getting changed. It is the same distance, same charges. So I can write k q1 q2 by r square. So now you should replace. Try to do it and get me the answer, please. எல்லாருக்குமே easy question தான் இது. Very basic question too. I wanted to get the option A, B, C, D. Do the calculation and let me know the answer in the comment box. So what will happen? Can I say 5f? I'm just multiplying this over here. 5f, which is equal to k q1 q2 divided by r square. And what is here? That is nothing but k q1 q2 by r square. So I can just go for 5f as the answer. Got it? And those who are coming, don't forget to like, okay, and share with your friends. We can study together. As I mentioned, more members, more energy, okay? And you should have a healthy competition between you guys, okay? I wanted to give the answer first, okay? So like that way we should approach. So again, another easy question. In an experiment, 3 microscopic lattice spheres are sprayed into a chamber and become charged with charges plus 3e, plus 5e, minus 3e respectively. All the 3 spheres came in contact simultaneously for a moment and got separated. Which of the following are possible values for the final charges on the sphere? Okay, very simple question. Okay, we have 3 charged bodies, plus 3e, plus 5e and minus 3e. Okay, and all these 3 spheres came in contact. After that, it is get separated. Now the charges will change. Okay, so what are the possible values? Easy question if you are very smart. Ninga smart na idu vandu konjam easy. Hi Kavin Saran, right? As I mentioned, if I am pronouncing anything wrong, correct me. எனக்கு வந்து Tamil is not that much good. Okay? So tell me the answer for this question. A, B, C, D. You have options now. Very simple question. You can find this with your logic side. Think about the properties of charges. That will give you the answer. We have studied the properties. Try everybody. And those who forgot to like, please. And do subscribe the channel. As I mentioned, we have lots of surprises coming on the way. This is a very easy question. Don't take this much of time. Okay. Is there any problem with the audio video? Please let me know. Okay. Guys, such an easy question. So we know that the charge will be always conserved. Okay. So we know how to add the charges as well. Additivity, right? So now I can just say that plus 3e plus 5e minus 3e, which is equal to the total charge is nothing but 5e. Okay. Now what happened? We know that the charge is conserved. So it cannot be more than 5e. So now you can just check on these options and just check which one is having 5 electrons or 5e as the charge. Now it becomes very easy. Try to do, guys, and let me know the answer in the chat box, please. Okay. So which one will be giving the correct answer? Here 6 plus 6 will be 12 and minus 7, this will be giving plus 5e. Okay. So that is going to be the answer. The only concept we have used here is conservation of charge. This is the only concept. Also additivity of charges. This is what we have applied here. I hope you got it. Okay. Everybody, please let me know on the chat box. Now moving on to another question. An object has a charge of 1 coulomb and gains 5 into 10 to the power 18 electrons. The net charge on the object becomes. Again, very easy question. Quantization of charge. What is quantization of charge? Q is equal to NE. So now it is having 1 coulomb charge. It is going to gain 5 into 10 to the power 8 electrons. Okay. Now what is the net charge? What is the net charge? At least this you should do it. Just the calculation part left. Okay. Everybody please try to do it. Everyone please try to do it. Such an easy question. You can give me ABCD options. Okay, how to do it? Now we have 5 into 10 to the power 18 electrons into what is the charge? 1.6 into 10 to the power minus 90. Okay, so you can just subtract that. I mean, already we have 1 coulomb, so you can just subtract this. Okay, then you will be getting the answer. So can you do it? Just you have to subtract 1 coulomb minus 5 into 10 to the power 18 into 1.6 into 10 to the power minus 90. So if I'm just rewriting this, I'll be getting 0.5 into 10 to the power 19 into 1.6 into 10 to the power minus 90. Okay, so now we have only 0.5 into 1.6. Can you just try it now? And just do the calculation, guys, because you people are not even responding. Please do the calculation and let me know the answer. Okay, I think I'm not getting the, oh, yeah. So I'm not getting the chat, I guess. So those who are getting the answers, and if there is any problem with audio video, please let me know. Are you guys getting it? Yes, Krishna Prasad, right? So just check the calculation again. Now it becomes more easy, right? So this will become 1 by 2 into 1.6. So it will be coming as 0.8. And then for the net charge, we can do one thing, 1 coulomb minus 0.8 coulomb. So that will be coming around 0.2 coulomb, and that is going to be positive. Hence option D is the right answer. Hope now everybody got it. Yes or no? At least நீங்க வந்து கொஞ்சம் effort, okay, you should put some effort. Otherwise na அந்த boards கூட tough இருக்க போறேன். Okay. Net வந்து definitely tough. If you are not even putting a single effort for at least solving the question, then it is going to be really tough. Okay. So now we are going for the another question. We have three charges, Q minus Q and Q naught. Here we have Q, here we have minus Q, and at the origin we have Q naught. And the distance between these charges is simply A, the magnitude of the net force on the charge Q naught. Okay, which means and the origin irukana charge ku what is it is experiencing, what is the net force it is experiencing. Adudha vandu nama yes, just try it. So now as I mentioned, if it is asked for the net force, first neenga vandu enna pananum and the direction mark pananum. Okay, so one is positive charge, another one is negative charge. So appo vandu in the force oda direction, what is going to be the direction, you can mark it. And again I'm reminding you, please do like the video, also share with your friends, let them come, we just rock the class. Okay, very good. So first we will mark the direction. So I'm just thinking about this Q naught and Q. Q naught is positive, Q is also positive. What kind of interaction it is going to be? Is it attractive or repulsive? If it is attractive, put A. If it is repulsive, put R. What is going to be the type of, it is going to be attraction or repulsive? Like charges, it will, what it will do? Repel. So this is the point charge. So we can just say this is going to be the force. Okay, this is going to be the direction of force due to this positive charge. Ipo vandu nama we will be doing with the minus Q. Q naught is positive and Q is negative, minus Q. So what is going to be that interaction? What kind of interaction it is? It is going to be attractive. Unlike charges will attract. So now we can just go for the direction like this. Now coming to the force part. Okay, what is the magnitude of force on Q naught by this plus charge? Okay, so I'll just simply put F due to the plus Q because it is just for the understanding. What is going to be that? What is going to be that? Of course, we can just mark K. It is 1 by 4 pi epsilon naught. So in the option also we have this 1 by 4 pi epsilon naught. So I'm just writing 1 by 4 pi epsilon naught into charges are Q naught into Q divided by the distance of separation is A and it will be A square. If I'm checking on the magnitude, the force due to minus Q, that is also coming as 1 by 4 pi epsilon naught Q naught into Q divided by A square. So the magnitude of these two forces are same, and the direction difference. Okay, direction mutually perpendicular. If two vectors are acting mutually perpendicular, what is the net force? What is the net force? It will be root of F1 square plus F2 square because these are all acting mutually perpendicular. So angle will be 90 degree, cos 90 it is going to be 0. Okay, so now we can go for root 2F because F1 is equal to F2. Now we got root 2F. So what is F? We already know it is nothing but 1 by 4 pi epsilon naught Q naught Q divided by R square. So now we can just go for root 2K Q naught A square. Option C is going to be the right answer. Now let us go for the next question. Now we have 4 objects W, X, Y, Z. Each of charge, this one is also having plus Q, this is also plus Q, this is also plus Q, and this is also plus Q. And these are all fixed at 4 points. And the length, or let's say the width or length, is going to be D. It is a square. And object X and Z are on the midpoint, which means this distance of separation will be coming as D by 2. And then the this one is also coming as D by 2. Now we should find what is the force, the electrostatic force exerted by the object W on this X is F. The force between them is F, and what is going to be the force on this Z? That is what the question. Yes, Krishna Prasad, very good, very good. Do the calculation properly because it is not about I have done quickly. It is all about what is the accuracy. Your answer is correct or wrong. And also in the CBSE board syllabus, you have to do one thing. Even if you don't know anything, at least for the numericals, whatever be the related formulas, at least you can just write that. Because for formula, you will be getting 1 marks. So it is better than getting 0. Okay. So if you have any numerical question coming, whatever be the formulas you feel like suits for this question, just write it. Done? Don't forget to like PYQ session separately we are doing, and in this session, this CBSE 12 series, the evening sessions we will be covering revision plus questions. Okay, so if you want PYQs only, if you're good in the theory part and everything, you can just attend those sessions. Okay, that will be I'll be conducting on Sunday, I guess. So I will just inform you in the next class. Okay, no worries. So let us do this. So how we can just start with this question? Okay, so now check first. It is given that F. What is F? The force on X due to W. So first I wanted to see mostly the high weightage chapters. Okay, I'm targeting like every day at least 2 chapters. So I think we can do something. Otherwise, if it is not, if the slots are not free, we will be going for high weightage chapters. But you don't need to worry anything. We are conducting mega marathons in the coming week. So be relaxed. Trust me, we will do it together. Okay. So now we can just go for the what is F? What is going to be F, guys? What is going to be F? We can say K. Let it be there. The charges are same. So I'm just writing Q square, Q1 into Q2. Divided by, what is the distance of separation, guys? Please tell me, what is the distance of separation? d by 2 the whole square. So d by 2 the whole square, which means d square by 4. D by 2 the whole square. So I'll be going for marking 4 over here. This is what F. Now what we need to find? We need to find the force on Z. Correct. So I'm just writing Fz, which is equal to, again, K. Okay, Q1, Q2 will be Q square divided by, now the confusion starts. What is going to be the distance of separation? So always the force will be acting along the line joining the two charges. This is what the key. So now I know this is going to be the line the connecting these two. So now I can just say that here only the force will act. Now I just need to know what is this length. Okay, what is going to be that length? I know this is a square, so this side is also going to be d. This is already, we know, d by 2. So what is going to be the hypotenuse, guys? Can you give me an idea about it? How we will be finding? Yes, this will be coming as root of d square plus d square by 4. And we need the whole square, so I'll be writing d square plus d square by 4. Got it? This will be root of d square plus d square by 4. Any confusion, anything, please let me know in the chat box. I will help you with it. Also, don't forget to like. That is my energy. I need some more energy, okay? So, we got this one. Now, I'm just rearranging. What I'll be getting? KQ square divided by, I'm just cross multiplying this. So, I'll be getting 5d square into 4. Now, we need this in terms of F. So, I'm just writing 1 by 5. What the rest I have? 4k q square divided by d square. What is this, guys? This is nothing but F. So, I'm getting the answer as F by 5. So, here is the option B. Everybody understood this question? Any confusion? Any confusion? Please just let me know in the chat box. Any confusion in this question? Please let me know. I will help you. Everybody understood this question? And in the madri ungalku concerns vanda comment la podungo. We will be conducting classes accordingly. Okay? Now let us move on to the next question. Simple question. A negatively charged object X is repelled by another charged object Y. So what is the given key? X is negative and Y is repelled. So definitely what will happen? That is also going to be negative. Now, however, an object Z is attracted to an object Y. Okay, now we have another one that is attracted. So that is going to be positive because unlike charges only will attract. Now which of the following is the most possibility for Z? So it can be neutral also will be get attracted, or positive agents. Such an easy question. Very good, Krishna Prasad. Next is an assertion reason. So you should tell me, is this true or false? Work done in moving a charge in a closed path in an electric field is always 0. It is from electric field, but we know. Okay, we will be discussing electric field after this. And electrostatic force is a conservative force. Very simple. Assertion and reason is true, and the reason is the perfect answer. Okay, the reason is the reason. Because whenever we are studying about the conservative force, this is what we will study first. For any conservative force, the work done in a closed path will be always 0. So both the statements are true and reason is the correct explanation. Now, two identical point charges Q each are kept 2 meters apart. We have Q over here, we have another Q over here, and this is what? 2 meters. This is happening in air. A third charge, point Q of unknown magnitude and sign, is placed on the line joining the charges such that the system is in equilibrium. Find the position and nature of Q. So basically, what is the meaning? Equilibrium. What is the meaning of equilibrium? Equilibrium, which means it is nothing but the net force experiencing on that is going to be 0. Understood? So the net force will be 0. Now we should know if we are keeping, okay, if we are keeping capacitance, it is going to be, I don't think like we can just go for it, but I will try. At least we will do the important questions and important concepts only. Okay, don't worry. If we couldn't take it today, we will do it in some other day. No issues. You can be relaxed. Okay, fine. So now equilibrium, which means the net force is 0. Now we have two charges and they are kept at 2 meters away, and we have another charge Q. Okay, another charge Q. So if I will be giving you few points, if you are getting this type of question, if both the charges are with the same polarity, either it will be 2 positive charges or 2 negative charges, then the equilibrium, if you need to get the equilibrium, the third charge must be in between the charges. So in this case, both the charges are positive, so definitely this will be in between. Okay, and now let us say, if it is unlike charges, one is positive, another one is negative, then definitely it will be outside the two charges, and that will be always in the line joining those two charges. Getting the idea what I said? If both the charges are same, you should be very careful. Write it as a note. If both the charges have same polarity, then the third charge, to get the equilibrium, it will be in between the two charges. If the charges are unlike charges, then the third charge will be outside the line joining two charges. And now let us say, if the magnitude is different, which one is having more one? Okay, let us say this side we will be having, I'm telling you, let's say this is 8 Coulomb and this is 4 Coulomb. Then definitely this force will be closer to the smallest charge. Now in this case we have an advantage. Two charges, two equal charges. So definitely if I'm keeping the third charge over here. Okay, so what will happen? If I'm just keeping this one, I will be getting a repulsive force due to this Q, and I will be getting another one in this direction as well. It will be get cancelled. Okay, in this case both charges are same, and we can straightly write the answer, which is equal to the distance of separation should be between them must be 1, because they are equal charges. That separation is 2 meters, so it will be exactly at the midpoint. Understood? Otherwise we can just do in this way. I'll show you the method. For the rest of the questions you can just go for this one. Don't forget to like, guys. Now check, I'm just taking this as x, and this will be coming as 2 minus x. So how to do this one? I'm just checking what is the force due to this one. K Q divided by x square, which is equal to K Q divided by 2 minus x the whole square. This one will be get cancelled, and we will be getting x square is equal to 2 minus x the whole square. So now you can just sort it from here. Okay, what we will be getting? 4 minus 4x plus x square, which is equal to x square. So this will be get cancelled, and we will be getting 4 is equal to 4x. X will be coming as 1 meter. So as I mentioned, if you wanted to follow this, you can follow. But again and again, I'm specifying because you know the timing and everything. So do in a smart way. So we will be, if it is identical, then the third charge will be definitely in between the two charges. If both the charges are equal in magnitude, then definitely it will be at the midpoint. Okay, now let us go for another one. We just wanted to know what type of charge it is. For that, I am just checking the charge on this Q. Okay, so tell me what is the charge on this Q. Tell me what is going to be that. First of all, the force due to, not charge, I mean the net force on this Q. What is going to be the net force? There will be a force due to capital Q. There will be a force due to small q. Now I'm going for it. What is going to be the net force? It will be coming as K Q divided by x square. Now I can just go for 1 square. Now this charge will also exert some force. So that will be coming as K Q square divided by 2 square. I'm writing it as 4. Okay. It must be equal to 0 because we are under equilibrium. If it is in equilibrium, the net force on the 0 ta. I mean, we don't have any confusion on it. So now we got this. What next? We will be going for minus kq square by 4. K gone, q square, q gone. So we will be having 4q which is equal to q. Okay, sorry, we need this one only. So on the q minus q by 4. So we got the magnitude and polarity. Potential primer, very good, very good. And Krishna Prasad, very good, very good, very good, super. Okay, now let us go for the another question. Again, we have two identical conducting balls, A and B. A is having minus q charge, B is having plus 3q charge. They are both in contact with each other, then they separated by a distance d. Find the nature of Coulombic force between them. What is going to be the force? Again, we have two bodies and that is the two conductors direct to contact. So if they are coming in contact, if only if they are identical, only if they are identical, after separating, the charge stored will be q1 plus q2 divided by 2. If it is identical, if the conducting balls are identical, the charge stored after this contact will be q1 plus q2 divided by 2. Okay, if it is not identical, they will transfer the charge till the potential become same. Okay, if it is not identical, we will equate the potential. Till the potential becomes same, they will just continue the charge transfer. So, இப்போ வந்து இந்த questionல இது identical. Identical na you can directly go for this one, q1 plus q2 by 2. Then you can find the force. Can you find it for me? Very good, very good, very good, super. So we can just go for q1 on the minus q plus 3q divided by 2. So we will be getting 2q by 2, which means the charge on the q. Okay, the charge on the q now, I mean both the charges are q, so it is going to be a repulsive force. And that force on the k q square divided by r. So next we have done few PYQs. As I said, we need to do more PYQs and the PYQ session is coming. That is why I said you should subscribe the channel, then only you will be getting the notification, and we should work on the numericals more. Okay, now itself I can see very few only responding for the questions. So I want many people to be in this chat. You have to be little bit more faster because in future we are going for the Neet exam as well. Okay, yes Gautam, Okay, very good, Gautam. So be attentive for the whole class and answer for all the questions and try to do by yourself. Okay. Now we are moving to the next topic, that is nothing but electric field. Electric field, na? Okay. So let us say if we open a perfume bottle in the classroom, we are all sitting in the classroom. இப்போ நாம வந்து அந்த perfume bottle open பண்றோம். What will happen? Yes, good smell is coming, right? Correct. So நான் இப்போ வந்து close to the perfume bottle, I'll be getting intense smell, right? Now I'm just going out to the class, so the intensity will be less. Okay. Thank you, thank you. Very good, very good, very good. Definitely we will let you know the schedule immediately. Okay. For Neet ku vanda daily classes classes vanda morning la irukku, so you can attend those sessions, and evening la vanda boards ku special classes. So now, yeah, let us focus. So now again back to the perfume bottle. We have a perfume bottle over there. Now I'm very close to the perfume bottle. Good smell is coming. Now I'm going to the next classroom. Intensity will reduce. Now I'm going out to the, I'm just going out. So I won't be even getting it. So this is what exactly electric field is. நமக்கு வந்து இப்போ ஒரு சார்ஜ் இருக்கு. இந்த சார்ஜோட இன்ஃப்ளூயன்ஸ் இருக்கும். இந்த ஏரியால ஃபுல்லா அந்த இன்ஃப்ளூயன்ஸ் இருக்கும். That influential area is known as electric field. Okay, that the space that the charge will influence, the influence of that charge, the whole space we will be call it as electric field. Okay, everybody understood? Okay, it is something like the perfume smell is spreading. So the perfume vanda in the charge oda influence, we will be getting the influence at some particular area, and then the space vanda electric field. Okay, and when we go away from the charge, the intensity will also reduce. Now I can just focus on the electric field intensity. Okay, now I can just go for the electric field intensity. Adu vandana very simple. E is equal to F by Q. Okay, and when you write this equation, you should specify one more thing. Adu vandu limit Q tends to 0 F by Q. I'll tell you why we are writing limit Q tends to 0. Q tends to 0 na, let us again back to the perfume bottle. Perfume bottle அங்க தான் இருக்கு. Okay, ஆனா நம்ம வந்து இப்போ another perfume use பண்ணிருக்கேன். So வந்து இந்த smell and the smell we will be having some different smell we will get. I won't be get exactly the same smell that perfume have. Exactly the similar way, if we have, we are taking one charge, it's a huge or large charge, then what will happen? We can't exactly get the influence of this source charge. Everybody got it? Everybody got it? What we are doing? நம்ம வந்து இந்த source charge இருக்கு, we will be taking a test charge. Why we are taking a test charge, or let's say a very small charge? Because in the charge oda influence puriyum. So adukku vandu we will be taking a very very small charge near to the source charge. That's why we are always keeping Q tends to 0. Got it? Okay, so electric field vandu ivlo da. Electric field na the influential area, and to represent this electric field we can use electric field lines. So electric field lines na, that is representing the electric field. Those are all imaginary. Okay, imaginary lines, electric field lines. These are all imaginary lines. Okay, imaginary lines. And if I'm going fast, you can just tell me, ma'am, you are going fast, I will reduce. Okay, because this is a revision class, so I wonder, like, we have to go little fast. So even if it is going too fast, please let me know on the chat box. I will reduce the speed. No worries. Okay, you can tell me at any point. Now we know electric field lines are the imaginary lines. And this will be always start from the positive to the negative. So if we have an isolated positive charge, then the field lines will be radially outwards. Field lines will be radially outwards. We have an isolated negative charge. These are all for the isolated charge. So for the negative charge, this will be radially inwards. Okay, and the tangent at any point will give you the direction of electric field at that point. Okay, if you need to find the electric field at any point, you can draw a tangent. That will give you. Understood? Next one, now we got tangent, okay, and this field lines never ever cross each other. So the reason, what is the reason? The direction. So if two lines intersect each other, okay, what will happen? At this point, if I'm drawing a tangent like this, here I should get another tangent. So one point la vanda two direction the possible illa. Okay, so that is why the electric field lines are not intersect each other. And another one, if these field lines are closely packed, okay, it is closely packed. If it is closely packed, then that represents it's a strong field. If there is a huge gap, that is representing weak field. So we have field lines. We have field lines that will never cross each other. If it is too crowded, which means strong electric field. If there is a huge gap, then it is going to be weaker fields. Okay, so now we got this thing. Now another one on the uniform electric field. Uniform electric field na enna? How we will get to know this is uniform electric field? This will be parallel lines with equal distance. Then we will say this is uniform electric field. Everybody got it? So what is uniform electric field? If the field lines are parallel and equidistant each other, we will say it is uniform electric field. For a plain sheet, okay, for a plain sheet, this will be like this. The field lines will be uniform. It will be equidistant and it will be parallel all the time. Hope you guys got it. Okay. So, yes, Manivel, hi. Okay. So now we have studied the properties of electric field lines. Okay, these are all important points you should know, then only you can solve the questions. Okay, so now we have studied the electric field lines, electric field. Now I'm going to find the electric field due to point charge. So what is the equation we have mentioned? Electric field will be F by Q, or let's say I'll be mentioned Q naught because we are taking the test charge. Okay, so now we know what is the force due to a point charge. What is that? K Q naught divided by Q naught R square. So we will be getting K Q by R square. So now you can tell me what is the unit of electric field? Force by charge. So the unit will be Newton per Coulomb. So in the next chapter we will be get another relation. I'll write it over here. E is equal to minus dV by dr. So from this we will be get another unit, that is nothing but volt per meter. Both the units one the important. Okay, so electric field one the F by Q naught, F by the test charge, and now we got for the point charge, that is nothing but KQ by R square. Got it, everybody? So this is what we will be studying in the electric field part. Okay. And in the electric field also, it is also changes with the medium, exactly the same way how the force changes. Here also electric field will change. Instead of K, I am writing 4 pi epsilon naught Q by R square. Q1 the source charge. Okay, Q1 the source charge. So it is depending upon only on source charge. It is not depending upon the charge which we are taking from anywhere. Got it? So now we got this. Another one. In any medium, this will be coming as 4 pi epsilon m Q by R square. Okay. Now I'm just rewriting this 4 pi epsilon naught epsilon Q by R square. Okay. So now I can go for K, that is what 1 by 4 pi epsilon naught divided by the relative permittivity Q by R square. Or otherwise, the electric field in the vacuum, or let's say in the free space or in the air, divided by the relative permittivity will be giving you the value. Understood, everyone? Everybody got it? Yes or no? So now we will be going for linear charge density, surface charge density and volume charge density, because till now we were talking about the point charges, right? So now we are going for the continuous bodies, because in the universal one we can't find the point objects, right? So if I'm giving the charge to any bodies, to any conductors, the charge will immediately distribute over the surface uniformly. So upper in the three terms we need, if that is a one-dimensional object like the wire, we will say linear charge density. What is linear charge density? In the small 1 unit length evlo charge irukku, adha linear charge density, dq by dl, or charge by length. That will give you 1 unit length evlo charge irukku. Second one, the surface charge density. We will represent it as sigma. Okay, that one the charge divided by area, two-dimensional objects like the sheets and everything. Third one the volume charge density. Volume charge density na the charge divided by volume. So like for sphere and all, we will be using the third one. Okay, so we will go for a 10 minutes break. After that, we will be continue with the electric dipole and the rest of the questions. So guys, you have to be here, take a break. You have to drink a lot of water and come back with full on energy. We will be back at 6:45. Okay, so everyone should come at 6:45. Okay, so take a break, just walk around and come back. See you. Hi. Let us just continue the session. So now இப்போ வந்து discuss பண்றது electric field. So we have discussed about what is electric field, in the electric field, I mean mathematical representation, how we will be finding electric field intensity. And also we have seen the linear charge density, surface charge density, as well as the volume charge density. Okay. So நாம இப்போ வந்து we have studied the principle of superposition in the case of forces. இப்போ வந்து electric fieldக்கும் நாம same, we will be doing the same thing. So இப்போ வந்து we have different charges and we just wanted to know, let us say இங்க வந்து Q1 இருக்கு, Q2 இருக்கு, Q3 இருக்கு, and we just wanted to know the field at this point. How we will be finding it? So we know the distance of separation. Let's say this is R1, this is R2, and this is going to be R3. Electric field also வந்து ஒரு vector quantity. Okay, so அது ஒரு vector quantity. அதனால we will also find the individual field. Okay, இப்போ வந்து Q1 னால இங்க எவ்வளோ, or let's say what is the electric field at this point. So we will go for E1 plus E2 plus E3. So this is how we will be doing the vector sum of all individual electric fields we will add, and we will be getting the net electric field at this point. Again, in the madri question, electric field, what is the electric field? And the question neenga vandu first how we have done in the force session, same like we will do it here. We will mark the force, electric field direction, then we will be solving it. இப்போ வந்து ஒரு பாசிட்டிவ் சார்ஜ்னா எலக்ட்ரிக் ஃபீல்டுக்கும் இந்த ஃபோர்ஸுக்கும் வந்து சேம் டைரக்ஷன். எலக்ட்ரிக் ஃபீல்ட், ஓகே, எலக்ட்ரிக் ஃபீல்ட் அண்ட் ஃபோர்ஸ் வந்து பாசிட்டிவ் சார்ஜுக்கு same direction. This is going to be the force which is equal to QE, because we have studied E is equal to F by Q. So F will be equal to QE. Now for a negative charge, if I am placing a negative charge in the uniform field, then we have studied the superposition principle as well. Now let us go for the important one, that is nothing but electric dipole. Okay, electric dipole. So electric dipole enna, very simple. We have two charges. And what is the speciality of these two charges? In the charge vanda plus Q na, in the charge vanda minus Q. Okay, so two equal and opposite charges, separated by a very small distance, and adu vandu we will call it as electric dipole. So நமக்கு வந்து இந்த electric dipole ஓட strength, what is the strength of this electric dipole? And the strength தான் electric dipole moment. Okay, electric dipole moment, the strength is called electric dipole moment. And how we will be finding it? We will represent it as P Q into 2L. Usually in the equation da everybody knows this equation. ஆனா இதுல ஒரு confusion இருக்கு. இந்த electric dipole வந்து ஒரு vector quantity, unit வந்து you know Q, the charge, that will be Coulomb, and length வந்து meter, so the unit வந்து Coulomb meter. Okay, it is a vector quantity and the unit வந்து Coulomb meter. ஆனா இந்த 2L, what is that 2L? So let us see, as I mentioned, two equal and opposite charges separated by a distance, and the distance the 2L. Okay, and from the center it will be L, and this is also going to be L. So dipole moment என்னன்னா charge into the distance of separation. முடிஞ்சா இந்த equation you have to study. ஏன்னா all the time you will multiply it with 2. Okay, and the mistake பண்ணாத. So dipole moment na charge into the distance of separation. It is both equal and opposite. So Q into the distance of separation. And why we are taking it as 12? Okay, why we are taking it as 12? Adukku ore oru reason da. In the next step, we will be going for some derivation. So there, if we are taking the distance of separation as L, we have to go for L by 2. Adu vandu konjam difficult. Okay, calculation vandu little bit hard. So adinala da nama in the distance of separation 12. We will be taking it as 12. So the half, the center to the charge, the distance will be coming as L. That's in the ideology. So எப்பவுமே நீங்க இந்த dipole moment என்னன்னா அதுக்கு in the definition you can go for charge into the distance of separation. Then no more confusions. Okay? And what is L? What is L in this case? The distance from the center to the charge. Okay, so those who are attending the session, don't forget to like the session and also subscribe, because you will be having lots and lots of surprises are coming for the board exam. So you have to subscribe, then only you will be getting the notification. Now we got the electric dipole moment. Vector na adukku direction irukkum. Inge in the direction vandu very simple, negative to positive charge. Okay, always vanda in the dipole oda direction vanda negative to positive da. Okay, so idu the basic idea. Electric dipole na two equal charges separated by a very small distance, and on the distance da in the 12. So in the strength, in the dipole oda strength vanda Q into 12. Okay, charge into the distance of separation. Direction vandu always from negative to the positive. Okay, so now it is the time for the derivation. So first of all, we are going for the most important derivation. That is nothing but the electric field due to electric dipole in the axial line. This is what the important derivation. Just check each and every step. You are not supposed to get stuck at any point. So write along with me, then only you will be getting it. So now we have the minus Q charge over here and the 12 distance. Here we have the plus Q charge. Okay, as I mentioned, the distance one the 12. Now from the center, I am taking a point in the axial line, and on the distance from the center is x, and in the half distance one the L, in the distance L. Okay, now we are going for it. So let me just start with the direction of electric field. Ipo vanda we have this positive charge, right? So to find the electric field, what we will do, we will take a test charge. Okay, and the test charge we will place here. Okay, so inga or positive charge, and force kum electric field kum vanda same direction for a positive charge. So they will repel, and the direction of force will be like this, and we will be having the electric field direction like this. Okay, now what we are going to do now? Let us just find the electric field due to minus Q. What is going to be that? Minus Q vanda, it is actually x plus L distance away, and x plus L nu sollumbodhu and the denominator la value vanda konjam adhigam. If the denominator is more, what will happen to the result? It will reduce, right? If now I will be asking a question, 2 by 5 or 2 by 10, which one is bigger? Of course, 2 by 5. Yena denominator small. Inge in the denominator, if I am writing E plus, what is going to be that? K, the source charge inge plus Q, divided by what is the distance? Center lirundhu x. In the distance L. and we need this distance, and other one the x minus L. The value is going to be small. Now I am going for E minus na K Q divided by, what is the distance of separation? Inga ஒரு L இருக்கு, இங்க ஒரு X இருக்கு. So X plus L the whole square. So if you are just watching, if you are just seeing these two values, you can see idhila வந்து denominator பெருசு. So this value will be less. And in the direction வந்து, this is going to be, that is a test charge, and this is going to be minus Q. So the direction will be like this. Okay. So the direction will be like this. This will be EQ minus. Okay, the field due to the negative charge. So both the fields are acting in the opposite direction. So now I can just go for the net electric field. What is going to be the net electric field? This is the major one, E plus minus E minus. Why I am doing this? Because both are acting in the opposite direction. So understand each and every step, then only you can do for the exam. This is an important derivation. Most of the question paper, if you check, if you're checking this, you will be get to know this is that much important. So now I'm going for the net electric field. So first one, the E plus na K Q divided by, we have X minus L the whole square minus K Q divided by X plus L the whole square. Now next step one, I will be taking this K Q outside. Now we have X minus L the whole square minus 1 by X plus L the whole square. Next what we will do? We will just cross multiply. So let us do that. KQ into X plus L the whole square minus X minus L the whole square divided by, if you are checking on the denominator, what is the denominator? Denominator na X minus L the whole square, X plus the whole square. Okay. So now we can just focus over the, okay, how we can just write it? How we can write it? Just think about it. We have X minus L the whole square and we have X plus L the whole square. What we will write in the denominator? Denominator le nama enna what we will be writing? You should tell me. Tell me. Yes, very good. So that is going to be X square minus L square the whole square, A plus B into A minus B. So that is the format coming. So we can just write it like this. Now I am expanding the numerator. What will happen? KQ into, okay, X square plus 2XL plus L square minus X square plus 2XL minus L square divided by whatever is the denominator. Now if we are cancelling this, what we are going to get? KQ into what is in the numerator? Tell me what left in the numerator. So everybody be attentive. This derivation is very, very important. What we will write? Yes, we will be going for X square gone, L square gone, and we will be getting 4XL divided by, we have X square minus L square the whole square. Now we can see that K, I'm just keeping there. Now we have 4XL. Okay, we have this 4XL. So if I'm writing it as Q into, we have the charge Q into 2L, okay, Q into 2L, we have this 2X left divided by x square minus L square the whole square. And tell me what is going to be this q into 12. Okay, audio video edachu problem irukka? Audio video, if there is any problem please let me know. Okay, so now k q 12, what is q into 12? 12 is the separation between the two charges. Now I will be getting here the equation. What is that? 2k, and this one I'm just writing it as p into x divided by x square minus L square whole square. Okay, இப்போ வந்து இந்த distance of separation வந்து it is going to be very less. Okay, comparing with the x value, if x is much larger than L, then I will remove this L square. Then what we have after that? 2kp x divided by x to the power 4. I will just write it as 2kp divided by x cube. This is the final answer. Okay, this is the final answer. And in the electric field, in the dipole momentum, on the same direction. When we are talking about the axial line, the electric field due to electric dipole, in the axial line, the field and the net field and the dipole moment, both are parallel, both are in the same direction. Everybody got it? Okay, hope everyone is getting the idea. So please let me know through the chat box, and also write each and every step here. Otherwise you will be get confused later. Okay. So very simple concept. நமக்கு வந்து two charges இருக்கு, minus q plus q. And in the minus q வந்து x plus L distanceல இருக்கு, and in the plus q வந்து x minus L distanceல இருக்கு. First step வந்து we will find the direction of electric field. Okay, and whatever we understood from the figure, that the electric field due to the positive charge is higher than the negative charge. Yena denominator. Okay, we already saw that. And after that we are just finding e plus minus e minus, then the just calculation, and the distance of separation is less comparing with the point where we are taking the electric field. Then we can remove L and we can just get this equation. So this is for the axial line. Now we are just going for the equatorial line. Everybody got it? Please let me know. If you understood, please give some likes. Okay, and also please let me know through the chat box. Now we are going for the equatorial line. So again, minus q inga irukku, plus q inga irukku, and the distance of separation vanda 2L, center point. Okay, and we will be taking a point x distance from the center, and here is the point P. Inga da electric field. Yes, very thank you so much. Okay, so inga da namukku on the field, the electric field, we need to find the electric field. So the first step vanda we will be finding the direction. So this is one the plus q. So we will connect these two charges, the line joining the two charges, and the force will be in the line lu mattum da irukku. Idu plus q, and we are placing a test charge. So adu vandu repulsion. And if you are just checking on the distance here, what will happen? This is going to be the electric field due to minus q. Okay, so now we know this angle theta. So this is also going to be theta because we are just taking it from the center. Okay, so now if this angle is theta, I am going to make this into components. Okay, we are going to make this E plus and E minus into components. So I'll be getting one component over here and over here. So this is, if this angle is theta, this angle is also going to be theta. So I'll be getting E cos theta, and here I'll be getting E sin theta. And next I'm going for making this into components. So this will be E sin theta, and again we will be getting E cos theta. So this is the diagram. From the diagram, the rest you can just do by yourself. Okay, how we can do it? How we can do it? So first of all, the electric field, the magnitude one, the due to plus Q, this one. What is going to be that? In the distance one, the L, this is coming as X. So this is the distance of separation. And the distance of separation in a, yes, very good. So this will be KQ divided by, we will be taking the square, so we will be getting L square plus X square. Okay, and what is due to E minus Q? What is going to be that? KQ, this distance also going to be the same, so we can just write L square plus X square. Idu varaikkum purinjada? Okay, if you have any doubts, you ask me. Now, we can see that the magnitudes are same. Hence, the sine theta term, E sin theta, will be get cancelled. Now we have E cos theta. In the direction 2E cos theta. So that is what our net electric field, 2E cos theta. Ini one the simple steps. Okay, we are going to substitute 2 into what is E? KQ divided by L square plus X square. First step is over. Cos theta. If this is the angle theta, so we will be getting cos theta as adjacent side one the L, hypotenuse one the L square plus X square. Substitute, done. L by L square plus X square. Now, the net electric field at the equatorial point will be coming as 2KQL divided by all raised to 1 plus 1 by 2. So we will be getting L square plus X square all to the power 3 by 2. Okay, everybody got it or what? Tell me yes or no. Yes or no in the chat box, please. Okay, so now again, whatever we have done in the previous section, we will be doing the same thing. If X is much greater than L, we can just remove the L term. So what you will be getting 2KQ, okay, we will be getting 2KQ divided by X cube. This is going to be what you will be getting. Here we have this L as well. Okay, now you can just check. I'm just rewriting K into 2QL divided by X cube. Again, we got P here, 2 into QL, or let's say Q into 2L. 2L is the distance of separation. Okay, whereas 1 by 2. 1 by 2 in the sense, this will be all raised to 1 by 2 because adjacent side, that is L, and hypotenuse one the L square plus X square all raised to 1 by 2. So if we are just checking on the powers, we will be getting 3 by 2. Okay. So now we can just write Kp by X cube. Okay. Now I can also make one more relation. In the equatorial axial one the enna connection. And the connection that we are going to discuss, E axial is equal to 2Kp by R cube. E equatorial one the, it is Kp by R cube. Okay, so now we can just say E axial is nothing but 2 times E equatorial. Done. Everybody understood? Okay, so this is the another important derivation. This also you can see either this axial line or equatorial line was asked multiple times in the CBSE board exam. So if you have any confusion, yedachu doubt irundha, you can ask me in the chat box now, we will sort it out. Okay. So now, can we go for the next topic? எல்லாருமே ரெடியா? Ready na? You just put a message in the chat box. Ready, ready, ready. Why you are not saying anything? Very good, very good. Okay. Damodaran yoga. Okay. Again, if I'm pronouncing anything wrong, please correct me. எனக்கு கொஞ்சம் கொஞ்சம் தமிழ் தான் தெரியும். நிறைய mistakes இருக்கும். Correct பண்ணிக்கோ. No issues. And everybody don't forget to like, share and subscribe. Okay. So now let us move on to the next topic. Are you guys ready? I don't think chapter 2 will work. As I mentioned, we can just discuss the important things and we can wind up, or otherwise I will make another separate video. Okay. Okay. Thank you, Damodaran yoga, right? Okay. So now we are going for torque. Let us say we have a uniform field. நமக்கு வந்து இந்த uniform field இருக்கு. Uniform field na enna parallel lines equidistant. இப்போ வந்து I'm just placing a dipole. Okay. We have minus q over here and plus q over here. Okay. Now what will happen? Definitely in the plus q வந்து it will experience a force. Okay. We will have a force and that will be parallel to this, which is equal to QE. And now tell me about this minus Q. It will also experience a force. But what is the difference? Can I let me know the chat box? What is the difference with the minus Q? Minus Q of force ku edho oru speciality irukku. You have to tell me in the chat box. All type of questions. You should work on PYQs. Also, we will be doing separate session for the expected questions. So you should attend that also. You have to practice. Yes, very good. It will be in the opposite direction. And we know this is an uniform electric field. If it is uniform electric field, na, in the two forces or a connection irukku. What is the connection? How I can write these two forces? How I can write the two force relation? You will tell in the chat box, I know. It will be equal. Okay, it will be equal. The force will be equal, but it will act as torque, right? There will be a rotational effect. The net force acting on the dipole, the net force acting on the dipole will be 0. Ana torque irukke. What is the general formula for torque? Why there is torque? Because two forces acting in the opposite direction. Rotational effect. Due to this, no translatory motion, right? And torque will be there. Torque oda general equation anna? Yes, the force into perpendicular distance. So QE, and what is the perpendicular distance? If this is making an angle theta with the field, tell me what is going to be the perpendicular distance. Let's say I'm just writing AB. What is going to be AB? Neenga da sollum. Okay, what is going to be AB? We can find sin theta, right? If I'm writing sin theta, what is sin theta? Opposite side na AB divided by hypotenuse. What is hypotenuse? What is going to be hypotenuse? It is going to be the length of the, very good. What is your name? Soski. I don't know how to pronounce it. Okay, I'm sorry. So this will be nothing but 2L. So nama AB vandu 2L sin theta. So I will be substituting here 2L sin theta. Now we have Q into 2L. Q into 2L na enna? Ovia. Okay, hi Ovia. Okay, this will be nothing but P E sin theta. And we know torque vandu vector quantity. Okay, torque vandu vector quantity. So we can just write torque is equal to the dipole moment cross E. Why we are taking cross? There is a sin theta. So this will be coming as P cross E or PE sin theta. Okay, now you should tell me few things which I really want to know. So if theta is equal to 0 degree, if theta is equal to 90 degree, if theta is equal to 180 degree, what are the things will happen? So first one, the theta is equal to 0 degree. Theta is equal to 0 degree. Now torque, what is the value of torque? What will be torque? Torque வந்து PE sin 0, sin 0 வந்து 0, so we will be getting torque 0. Okay, and 90 வரும்போது it will be again sin 90, sin 90 is 1, so we will be getting the maximum torque. So அப்போ வந்து first question, when we will be getting the maximum torque? அதுதான் என் first கேள்வி. What is that? It is going to be PE when theta is equal to 90 degree. And what will happen when 180 degree? Adu 0 da. Correct? Because sin 180 also 0. Very good guys, very good. Good response. Fine. So this is what actually happening. Now we got the torque. Okay? We got the torque. We know which are the points where we will be getting the maximum torque as well as the minimum one. Okay, when it is parallel or anti-parallel, the torque one is 0. Otherwise, if it is 90, the torque one the maximum value. Any confusion, anything with anybody? Anybody is having any confusion? Now, yes, very good, thank you. So we got the torque. Next one, we have did with uniform electric field. If it is in non-uniform electric field, you should tell me what are the things will happen. If I am placing minus q plus q, what will happen? In the dipole ku enna agum? Force irukuma? Dipole will experience any force, yes or no? Tell me yes or no. Dipole ku edach force experience? There will be force, right? Because yena force kuda equation QE. Electric field one different. Okay, electric field both the points it will be having different values. So field different na, definitely force is also going to be different. அப்போ வந்து the net force இருக்கும். Okay, the net force இருக்கும். Net force இருக்குன்னா இதுக்கு translatory motion இருக்கும். Torque கூட இருக்கு. Okay, there are two forces acting. Okay, so definitely torque will also be there. It will exhibit rotational motion. So நாம வந்து in the electric dipole, if you are keeping in the non-uniform electric field, it will experience force. It will experience the torque. Both translatory and rotational motion will be happen. Okay, and also one possibility is there. Ipo na edukra in the 2 points A and B. Okay, even if it is non-uniform, maybe in the rendu point la vanda field is same. Again, force can be 0. Net force can be 0 in non-uniform, but it is not necessary. Purinjiducha? Okay. So now let us go for some of the questions, then we can just go for the other thing. We have 2 point charges plus q and minus q located at x is equal to 0 and x is equal to L respectively. The point on x at which the net electric field is 0 due to the 3 charges. Okay, so how we will be finding it? We have 2 point charges. Okay, we have 2 point charges. What are the charges? Plus 8q, that is at the origin, and L distance away yaar irukku? Yes, we have this minus 2q, and the point on x axis at which the electric field is 0. Okay, நம்ம வந்து electric field 0 ஆகிற point we have to find. எப்படி find பண்றது? ஏதாச்சும் ஐடியா இருக்கா? Same like force, whatever we have done. We did the question in the force. Exactly, and the same type question tha. Okay, so rendu different charges na, unlike charges na, polarity different na, the null point will be not inside, not in between the two charges. That's the first point. And always it will be close to the smallest charge. So I'm assuming the charge, the third charge, the test charge, we are keeping at this point. And let me just take this as x. Okay, now we need to find the distance from the origin. Now you can assume at this point the electric field is 0. Okay, so how we can just do it? The field due to minus 2q, which will be supposed to be equal to due to the plus 8q. So try it, everybody. Those are coming new, you have to like the video also. You should share with your friends as well. Okay, don't forget. So tell me what is going to be the electric field due to minus 2q at this point. What is going to be that? Of course, k into 2q divided by, what is the distance? L plus x minus 2q na. So only x square. In the x square mattum. Okay. Next one the 8q charge. Adukku vanda 8q divided by L plus x the whole square. Now you can equate and you can find it. Find x. And once you get x, you should add it with L because we need to know the distance from 8q. So let us do this. So q get cancelled the value. Now try to find it. Just cross multiply. So root 2L plus root 2x, which is equal to root 2x. Try everybody. So you can just find the answer, please. I have given all the steps. Now it is just 2. If you're getting the answer, just put in the chat box, please. Just the calculation left. You're getting D. As I mentioned, once you're getting X as D, very good, X will be coming as L. That is true. But we need to find the distance from the origin. So already this is the origin. 8Q is at the origin. So L plus L will be coming as 2L. Okay, so the answer will be coming as 2L in this case. This is a major mistake everyone used to do. Once you got X value, you will be mark it as the final answer. But in this case, L is the distance from the minus 2Q. And if you are comparing from the origin, it is going to be L plus L, 2L. Okay, now let us go for the next question. The magnitude of electric field due to a point charge is 2Q. Okay, magnitude of electric field வந்து 2q at a distance r is E. Okay, so we have a 2q over here. R distance la வந்து அந்த electric field E. Okay, R distance la electric field வந்து E. Then the magnitude of electric field due to uniformly charged thin spherical shell of radius R with the total charge Q. Now we have a shell with the charge Q and we should find the field at R by 2. What is the field at this point? So in the spherical shell oda speciality enna, in the spherical shell it will be act like a point charge. Okay, so you can even consider this is something a point charge which is having charge Q. So now in the electric field, in the first case electric field da find panna pore, K into 2Q divided by R square. And in the electric field K into Q divided by R square by 4. So I'll be getting like this. Now we will be doing one thing. We are just rewriting this 2 into 2kq divided by r square, and this is nothing but E. So we will be getting 2E as the answer. Simple question tha. We are moving to the next question. So again, assertion reason. A negative charge in an electric field moves along the direction of electric field. It is wrong. It will be opposite to the electric field. Reason, on a negative charge, a force acts in the direction of electric field. Wrong again. Both assertion, reason are wrong. Very good, Sok. Okay. Now we have done the electric dipole, so we can just go for the questions directly. An electric dipole placed in an electric field intensity. So E is given as 2 into 10 to the power 5 Newton per Coulomb, and theta is given as 30 degree, and it experiences a torque that is equal to 4 Newton meter, and the dipole length is 2 into 10 to the power minus 2 meter. What is the charge? Which equation we can use, guys? Which equation we can use? Torque is equal to PE sin theta. In the P Q into the distance of separation 2L into E sin theta, and 2L okay, Q into what is 2L? 2 into 10 to the power minus 2. 2L na the total distance of separation. You don't have to multiply it again. Okay? Into 2 into 10 to the power, what is the field? 5. Okay? Then sin 30, which is equal to 4 Newton meter. Idilaranda we have to find it for Q. Can you find it now? And get me the answer in the chat box. Quickly you can do it. Just do the calculation. The rest of everything is done. Try it. Everyone just try to do the calculation, because calculation speed also matters in the board exam as well. Okay, very good. So we will be substituting the values. So let us do Q into 2 into 10 to the power minus 2 into 2 into 10 to the power 5 into 1 by 2. So 2 will be get cancelled, and the rest we have minus 2 and 10 to the power 1, it will be coming as 3. So we will be getting Q into 2 into 10 to the power 3. Now 4 divided by 2 into 10 to the power 3 will be giving you the charge. So that is nothing but 2 millicoulomb. Hence option C is the right answer. Very good. Let us go for another question. An electric dipole placed in a non-uniform electric field can experience. Quickly you can give the answer. Quickly. A, B, C, D. An electric dipole placed in a non-uniform electric field. Non-uniform electric field. What will happen? Very good. It will be having a force as well as torque. We have already discussed this thing. Now, if a dipole were kept in a uniform external electric field E0, diametrically represent the position of the dipole in a stable and unstable equilibrium and write the expression for the torque acting on the dipole in both the cases. Okay, so now how we will be finding it? We just wanted to find the torque. What is the torque? How we will be finding it? We know that there is two forces acting on the this dipole. Adla vandu equal and opposite. Adanala no net force. Ana adukku torque irukku. And adu vandu P sin theta. We already done the derivation. Okay, so we will be going with that, and very easy question we already done. The second question also we have done. When we have the expression, we need to find the expression for the torque for a electric dipole. So just we have to go through the, we will be getting the pattern. Now, two identical point charges Q each are kept 2 meters apart. We have Q, another Q. This is 2 meters away. A third point charge Q is unknown and it is placed in the line joining the two charges and it is remains in the equilibrium and the nature of Q. I think we have done this question, so I'm just skipping it. Okay. So questions are over. Now we are going for the another important concept, that is nothing but electric flux. Electric flux na enna? Okay. So நமக்கு வந்து ஒரு சார்ஜ் இருக்கு. அந்த சார்ஜோட இன்ஃப்ளூயன்ஸ் ஷோ பண்றதுக்கு தான் இந்த எலக்ட்ரிக் ஃபீல்ட் லைன்ஸ் இருக்கு. சோ எனக்கு வந்து ஒரு சர்ஃபேஸ் இருக்கு. ஓகே, அந்த சர்ஃபேஸ்ல இந்த ஃபீல்ட் லைன்ஸ் will just go through it. Okay, that number of field lines. Okay, in the flux na very simple, it is electric field lines da, nothing more. But in the electric field line supposed to pass perpendicular to the surface. That is the only difference. Electric flux na field lines. And the field line ku konjam criteria irukku. Adu vandu perpendicular. It should go perpendicular to the surface. And the flux we will be represented as, okay, in the electric flux vandu we will be represent as phi, which is equal to E dot A. So we have to check this thing. Okay, flux வந்து ஒரு என்ன சொல்றது scalar quantity தான். Okay, flux வந்து scalar quantity தான். Okay, அதுக்கு direction எதுவும் இல்லை. Second வந்து இதோட யூனிட்னா we know electric field வந்து Newton per Coulomb, area வந்து meter square. Okay, otherwise we can also go for volt per meter into meter square. We have another unit, right? So இது வந்து volt meter. So we have two units for the flux. Scalar quantity the mathematical representation வந்து E dot A, EA cos theta. The magnitude வந்து EA cos theta. Okay. I'm not getting you, ma'am. How to attend to numericals? Ma'am, we not even no questions normally. Okay, you can't understand the question or what? Okay, we will do the numericals session. You don't have to worry. Don't get panic. Be ready. Just wait. You will be getting all the required things on time. Okay, trust me. Trust the process. Okay, so we have this electric flux. Electric flux the unit the voltmeter. Illena we can just say Newton meter square per Coulomb. Okay. Now I am introducing area vector. இது வந்து ரொம்ப important. Area vector வந்து ரொம்ப important தான். In the area vector, area always, it is not going to be vector always. In some situation இது வந்து vector தான். Okay, ஏதாச்சும் physical quantity. Okay, there is a physical quantity which is passing through the surface. Okay, and due to this area, okay, if let's say I'm just placing like this, let's say the field lines are passing through it. Now I'm just tilting a little bit. So the number of field lines passing through the surface is going to change. And the time we will consider area as a vector, not always. Okay, edachu physical quantity in the surface load pass பண்ணும்போது at some point due to the orientation there will be some changes in the physical quantity. And the time we will consider area as a vector. And the direction வந்து always perpendicular to the perpendicular to the surface. Always one the perpendicular to the surface. That's ഏറ്റവും important. Okay, always. If it is like this, let's say the surface in XY plane, what is going to be the direction of area vector? It is going to be in the Z direction. Okay, and we have this type of what to say open and closed surface. Closed surface now like a sphere, that will be always outward, the area vector. Open surface now, let's say we are taking a plain sheet. What will happen? The area vector can be perpendicular towards this side as well as towards this side. As per the requirement, we can just see. Okay, understood? Okay, so this is what area vector. So flux, we will be write it as EA cos theta. If the electric field is uniform. Now we are going for something very, very important, and most of the question paper will ask this question, Gauss's law and its applications. Okay, so we should know what is this Gauss's law. Okay, so what is this Gauss theorem? So that is what we are going to write. Okay, so I will write the mathematical representation, closed integral E dot ds, which is equal to the charge enclosed divided by epsilon naught. So in the Gauss's theorem, study பண்றதுக்கு முன்னாடி, we should know what is the Gaussian surface. Gaussian surface na enna? Gaussian surface na very simple. அது வந்து ஒரு imaginary space தான். Okay, and in the Gauss's law, Gauss's theorem apply பண்றதுக்கு, in the Gaussian surface we have to consider அது வந்து necessary. Okay, Gaussian surface வேணும், இல்லைனா Gauss's theorem we can't apply. Okay, so இப்போ வந்து we have a non-uniform, or let's say we don't have a uniform electric field. அந்த டைம்ல எப்படி we will be finding the magnitude, or let's say how we will be finding the electric field. So அதுக்கு தான் இந்த Gauss's law, Gauss's theorem we are using. Okay, closed integral na இந்த Gaussian surface வந்து 3D and இது வந்து closed surface. So in the closed surface la ipo nama oru charge place pannina, in the field lines will go through the surface, and then we can find the flux. And the flux oda value vandu charge enclosed and the Gaussian surface kulla evlo charge irukku and the net charge divided by epsilon naught. இப்போ வந்து எனக்கு ஒரு Gaussian surface இருக்கு, ஒரு sphere தான், 3 dimensional. இங்க எனக்கு Q1 இருக்கு, Q2 இருக்கு, Q3 இருக்கு. So when I'm finding the flux, what is the net charge enclosed? What is the net charge enclosed? Q1 plus Q2. Okay, எனக்கு வந்து இங்க ஒரு minus Q1 கூட இருக்கு. Minus Q1 கூட இருக்கு. What is the net charge now? It is just Q2. Q1 minus Q2 plus Q2. So the charge enclosed one, it is nothing but Q2. Okay, we will just add the charge, since it is a scalar quantity, we will add with the sign and we will be getting the value. Understood or what? Yes or no? Can I get an yes or no in the chat box, please? Please, please, please. I just wanted to know you people are there, or you just playing the video and just going. So just make sure your presence. You guys are getting this, yes or no? Yes, thank you, thank you, thank you. Yes, and those who are coming, don't forget to like. Okay, after this we are going for the application of Gauss's theorem. Okay, adu vandu romba important, and the derivation most of the exam la ketittu irukken. Okay, I want your full attention in this. Okay, so ipo nama vandu we are going to do one thing. We should prove Gauss's theorem, right? We should prove Gauss's theorem. So here is the proof. So in the proof 2 marks multiple times ketittu irukku, so we can just go for this. Very simple. எனக்கு வந்து ஒரு charge இருக்கு Q, அது வந்து ஒரு Gaussian surface ல, அந்த Gaussian surface select பண்ணும்போது we can choose any shape. There is no such condition that you should go for a square, you should go for a sphere, whatever it may be, you can choose. No issues at all. It should be 3-dimensional. Okay, and this Gaussian, whatever be the shape of this Gaussian surface, it is not affecting the Gauss's law. Okay, why we are taking the sphere and all? Because if we are just taking any random shape, we should find the area, right? The integral ds we should find. So we can't. That is why we are taking some shapes which we already know the area. So in the point charge, I will consider a sphere. Okay, sphere, in the sphere, the n Gaussian surface. So if I'm just checking on this charge, I can see that there is the field at the surface of this Gaussian surface. Now, if I'm taking any point, the field will be same. Okay, the field will be same because equidistant point charge, due to a point charge, the field the k q by r square. So r the same for the surface. So field the same. And what is the Gaussian theorem? It is E dot ds. And electric field the constant, and the value in the radius, if we are taking as capital R, இது 1 by 4 pi epsilon naught q divided by r square. Now integral ds. Integral ds, now we have to find the area of the sphere. What is the area of the sphere? What is the area? 1 by 4 pi epsilon naught q by r square. The area 4 pi r square. 4 pi gone, r square gone, and what we have after that, the charge enclosed in the Gaussian surface divided by epsilon naught. Purinjiricha? You are getting my point. Is this the board exam? It is board exam. Yes. Okay. So now we have proved that this, this is the proof for the Gauss's theorem. Now another 2 mark question Gauss's theorem use panni eppadi Coulomb's law prove pandrathu. Okay, so we can just do that as well. Again we are deriving. These are all questions, multiple times asked questions. Deriving Coulomb's law from Gauss's theorem. Okay, so now we will be starting with the theorem E dot ds. What is E dot ds? Okay, for a point charge we already found it. It will be coming as 1 by 4 pi epsilon naught q divided by r square. Okay, now we are taking E here and we will be getting, because we have to find the force, right? So force will be equal to Q into E. So what we are finding is, we are going to find the electric field. Okay, once we got the electric field, we can just multiply here Q into E. Okay, it feels slow, really. Okay, fine, I'll go first. Okay, so now we will be getting 1 by 4 pi epsilon naught Q by r square. Okay, and in the ds the very small area, and we will be getting the what to say, our electric field as 1 by 4 pi epsilon naught q by r square. Okay, everybody. So Coulomb's law, if we need to prove Coulomb's law, the first thing what we need to do is, we should consider the point charge, and the point charge will be producing some electric field. So we will be considering that electric field, and after that we will be equating with F is equal to QE. Okay, so 5 on the E into 4 pi r square, and we will be getting it as we will be getting the flux, which is equal to E into area. So E, which is equal to E, which is equal to what we will be getting? We will be getting, E into area 4 pi r square, and which is equal to Q by epsilon naught. So E will be Q by 4 pi R square epsilon naught. So now I'm going to substitute here. So that will be coming as 1 by 4 pi epsilon naught Q into Q divided by R square. Just you have to apply the E equation over there by finding this. Okay, done. Yes. So now we are going for the applications of Gauss's theorem. So first application one, the electric field. Okay, electric field due to an infinitely long wire. Okay, so let us say we have a wire over here. This is, let's say, positively charged. So as I mentioned, the charge will be three-dimensional. It will be, this is the wire. So the field will be in this direction. So everywhere, towards every direction, it will be producing the field. So now I just wanted to know the field at a point P. Okay. So the first step வந்து நாம வந்து அந்த Gaussian surface consider பண்ணணும். Gaussian surface consider பண்ணும்போது in the point wherever we wanted to find the electric field, on the point we have to include in the Gaussian surface. So நான் இன்னைக்கு I will be taking a cylinder shape. The Gaussian surface, whatever I'm taking is nothing but cylindrical shape. And the radius one the R. Okay. So, in the cylinder, three faces. The curved surface, in the flat two surface, up and down, there are two flat surfaces as well. So, if I am finding E dot ds, the flux, I have to consider the flux through three surfaces. One in the curved surface, another one the flat surface. So, let me just mark this as the curved one. This is the flat, this is another flat one. So, idhula vandu E ds for the first one, curved one. Second one vandu 2, third one vandu 3. So, we know this is how we will be doing it. Ana, inga oru problem irukku. Two flat surfaces. Area vector vandu ippadi, field vandu ippadi. So, area vector field perpendicular. Angle between them 90 degree. So, in the flat surface ku vandu in the flux will be coming as 0. Flat surface. Yena field area vector it will be making perpendicular, or let's say 90 degree each other. 90 degree na cos 90 0. So the flux through flat surfaces will be 0. So I'm going to say this will be 0. Next one, in the electric field, if I'm just taking the electric field at the surface of the cylinder, can I say it will be same? Can I say it will be same? Yes or no? Of course I can, right? Of course I can. Why? Why I'm saying this? Tell me the reason. Because equidistant, right? The charge to the surface, the equidistant. So field is going to be uniform at this curved surface. So field, I'm just marking field, and now integral E ds, the area of the curved surface, that will be coming as 2 pi into the radius into the length. Okay, length one I'm taking L. So ipo vanda we will be getting E2 pi r L, which is equal to the charge enclosed divided by epsilon naught. Now what I want E. So I can write Q divided by 2 pi r L epsilon naught. So I'm just going to rewrite in different formats. What are the different formats? So now Q, I can just write it as we have already studied linear charge density. So that will be lambda L, which is equal to Q. So lambda L divided by 2 pi epsilon naught L. So L will be, R is also there. L will be get cancelled. And what we have after that? Lambda by 2 pi R epsilon. So this is what the equation. Now, Again, I can just do one thing. I'm just going to multiply and divide with 2. 2 by 2. Okay. Lambda by 2 pi epsilon naught r. So now I am getting 2 lambda divided by 4 pi epsilon naught r. So I can write k2 lambda divided by r will be coming as the final answer. So you can just choose any final answer. If you are comfortable with this equation, you can go for whatever you want. Everybody understood this one? All are getting what I'm saying? So those who are coming new to the channel, subscribe. Also like this video. Okay? Now we are going for another important derivation. So we have a infinite sheet. So electric field due to infinite sheet. This is what we are going to discuss. Idutha inneki discussion. Okay? You should work hard. Okay? That is what you need to do, Jasveer. Okay, nothing else. Just work really hard and prepare from now itself. You can't be lazy. That's it. Okay. So now infinite sheet. So right now we have an infinite sheet. It is charged, positively charged. We will be considering a point over here, P. Now, what I wanted to find the electric field at the point at P. Adukku I will consider a Gaussian surface over here. Here I am just considering a cylinder. You can choose any shape. As I mentioned, there is no restriction. Okay. So, infinite sheet, the field will be like this. Okay, field will be going like this as well as this. So, now my question is, I will be considering few areas. Let's say this is what A1, this is what A2, and this is what A3. The curved portion and the flat two surfaces. In the moon surface, which one all have the flux? Can you give me an answer? A1, A2, A3. Of course, in the flat surface, right? Correct. So in the flat surface, we can just see that the area vector will be like this. Here it will be like this. And that is in the direction of field, because the field lines ippadi. This infinite sheet. Adoda field direction, it will be uniform and parallel. So I'm taking a point over here. Exactly in the same distance, I'm finding a point over here. So now the flux will be coming as, again, we will be starting with this equation E dot ds. Okay. So now I'm going to check what will happen with A1. A1, the area vector and field vector, always it is going to be perpendicular. Always it will be perpendicular. Got it? So there is no flux through the curved surface, only through the flat surface. And that is though, let's say the area is A. Both the area at the flat surfaces will be A. Appadina, so E into 2A, because this area as well as this area, which is equal to the charge enclosed divided by epsilon naught. Now, E will be coming as Q by 2A epsilon naught. Now, how can I write this Q? Q eppadi change pannala? We know surface charge density, sigma A by 2A epsilon naught. So, sigma by 2 epsilon. So, this is what the electric field due to an infinite sheet. Purinjada? Any confusion? Edachu doubt irunda? You can ask me now. Everybody, you have to be very careful about these derivations, because these are all coming for 5 marks. Application of Gauss's law, 5 marks. Now we are going for the third one, the long one. Let us do this. The spherical shell. Okay, spherical shell, now hollow sphere, nothing inside. Okay, so if there is nothing inside, the charges will be at the surface. Charges will be at the surface. Okay, so if there is no charge, okay, I'm talking about inside point, the charge is equal to, yes, the charge is equal to 0. So electric field enna? According to Gauss's theorem, in the case, what is going to be the electric field? You can give me the answer. Also, don't forget to like. So, in this case, what is going to be the electric field? What is going to be the electric field? Tell me, tell me. It's going to be 0 because according to Gauss's theorem, it is equal to charge enclosed divided by, very good, Purva. Okay, charge enclosed will be coming as 0. So, electric field also going to be 0. So, for a spherical shell, this will be coming as 0. Understood? Okay. Now, I am considering at the surface. At the surface, also I am going for outside. So, in the spherical shell, if I am just finding the force at this point, field at this point P, the radius is R and this distance is small r. So, in the case, in the sphere, the point charge, it is like a point charge. Point charge, we know what is going to be the electric field. It is coming as 1 by 4 pi epsilon naught Q by R. Right? Okay. So, very simple. We will be, if we are substituting in the equation also, E dot ds, which is equal to Q by epsilon naught, E into, what is ds? 4 pi r square, because we are considering a Gaussian surface like this, including that point. Okay. So, which is equal to Q by epsilon naught, and we will be getting KQ by r square. Okay. If r is equal to, at the surface, what will happen? This r will be equal to capital R. So, the field will be coming as KQ by capital R square. So, in the spherical shell, romba easy. Yeah, we don't have to think much. Next one konjam problem. Okay, what is that? What is that? Spherical shell kapram namukku solid sphere irukku. Okay. Solid sphere la enna panna pora? Solid sphere la enna panna pora? You can tell me what will happen. What about the outside electric field? What about the outside electric field? Outside electric field. It will be same as spherical shell, right? So, I'm going for non-conducting solid sphere. Okay. So, in the case, we have a solid sphere. The charge is distributed throughout the sphere. And outside, if I'm taking a point, okay, the distance the small r. Again, I will do the same process. We will be considering a Gaussian surface, including that point, and outside it is same as what we did in the previous case. It will be, the electric field will be KQ by R square. At the surface surface KQ by R square. Inside konjam confusions irukku. Okay. Yena, we are going to find the electric field inside the solid sphere. So again, I am considering the solid sphere and I am going to find the field at this point. This is the center. So this distance is, let's say, small r. So what is the first step? We will consider a Gaussian surface including that point. We will do the first step. Let's do it together. We have done the Gaussian surface part. Now we got the Gaussian surface. The radius of the Gaussian surface is r, and the radius of the sphere is coming as capital R. Now the problem is, what is the charge inside this Gaussian surface? Total charge on the Q. In the Q, evlo charge on the small sphere, radius small r la irukku. Adudha we need to find. How we will be finding? Can you give me an answer? Adukku we have already studied rho. What is rho? The charge per unit volume. So I will be writing Q divided by 4 by 3 pi r cube. Unit volume வந்து இவ்ளோ சார்ஜ் இருக்கு. ரோ சார்ஜ் இருக்கு. யூனிட் வோலியத்துல ரோ சார்ஜ் இருக்கு. ஆனா இப்ப வந்து எனக்கு வேண்டிய வோலியம் 4 by 3 pi r cube. Okay, the required volume is 4 by 3 pi r cube. எனக்கு இந்த சார்ஜ், இந்த ஸ்பேஸ்ல இருக்கிற சார்ஜ் மட்டும் போதும். Okay, so we have the charge in a unit volume that is equal to rho. So if that is rho, tell me for this much of volume, in unit volume this much, so for this much of volume, like 4 by 3 pi r cube, what is going to be the total charge? I can just simply multiply it with rho. Okay, now the problem is sorted. Again, closed integral E dot ds, which is equal to Q by epsilon naught. E the constant and ds the we have to go for 4 pi r square, because that is for the Gaussian surface, which is equal to the charge the rho into 4 by 3 pi r cube divided by epsilon naught. So now E the rho 4 pi r cube divided by 3 epsilon naught 4 pi r square. So we will be getting rho into 4 pi gone, r cube and r square. So we will be getting r divided by 3 epsilon naught. So this is going to be the field at the, inside point, varying with r. Okay, when r changes, this value will also change. When r increases, what will happen? The field will also increase. Now the turn is here. Okay, we understood whenever we are finding this r value, we got the point that this is increasing. It is a linear relation, which means I'll write the equations again. For the solid sphere, E inside is proportional to r, E outside is proportional to 1 by r square. So now in the E and R, I am going for the graph. So in the time, what will happen? Till this R becomes capital R, இது linear. The linear na, it is proportional to R. அதுக்கப்புறம் the graph will go like this. This is representing 1 by r square. This is proportional to R. So graph will be like this. The same thing if I'm going for spherical shell. If I'm going for spherical shell, what will happen, guys? Yes, E inside, it is equal to 0. E outside, it is proportional to 1 by r square. So the graph will be like this. It will be 0 till r is equal to r. And it will be starting from the maximum point and it will reduce 1 by r square. So this is how the graph will be. So this graph is also important. You can expect questions based on this graph. Okay, so you should have a clarity. And as I mentioned, applications of Gauss's law is very, very, very important. So don't forget to study. And if you have any confusion with any of the derivation, you can ask in the chat box. If that's a doubt in the chat box, you can ask. Otherwise, comment la poduko, like in the derivation separate, I will do a video and you can just watch it. Okay, everybody is ready for the next question practice session. Are you guys all ready? Can I know in the chat box, guys, please, please. Are you guys ready for the question practice? Tell me, ready, ready, ready. Are you guys ready for the question practice? Tell me yes or no. So now we are going for the, yes, Shailaja, yes. So we are going for the first question. An electric field is uniform and acts along x-axis in the region of positive x. It's also in the minus x direction as well. The value of the field is 200 Newton per Coulomb when x is greater than 0, which means positive x side is 200, negative x side is minus 200. A right circular cylinder of length 20 centimeter, radius 5 centimeter, and its center is at the origin and its axis along x-axis, so that one flat face is at x is equal to plus 10 and another one is x is equal to minus 10. So you have to do one thing. First of all, try to analyze and draw the figure first. Okay, I'm not giving you any instruction. Just take your time and just first you have to draw the diagram. Whatever is given in the question, try to draw the diagram first. Okay, that is the first step. You should do it now. Everybody. Because if you could draw the diagram, answer is half done. Then you know the process. That's why I'm saying try to draw the diagram first. So please try to draw the diagram. Okay. So what is happening here? Here we have the axis like this and the cylinder is here. Okay. Cylinder is here. The lengthwise, that's why Z, the flat surface is at plus 10 centimeter as well as this will be at 10 centimeter and the radius is 5 centimeter. So this will be 5 centimeter. This is also going to be 5 centimeter. This is the scenario given in the question. Now, what is the question? The net outward flux through the cylinder. How we will be finding the flux? We know the flux equation is nothing but E dot ds, right? So, can you find it now? Try. Everybody, please try. So, you can go for finding the flux. Just go for E dot ds. What is going to be the area of the flat surface? Pi r square. And you have the r value that is given in centimeter. So you can just convert into meter and you can go for it. So now let us go for it. So I'm just considering this surface. Okay, I'm just considering this surface. So we can just see that the E value, okay, we have this E into area. Okay, area will be coming as pi r square. Okay, field is already given in the question, which is coming as 200, and in the negative direction that is minus, and pi into r square minus 5 into 10 to the power minus 2 the whole square. Okay, so try to do this. And this cos theta will be coming as 1 because these are in the same direction. Okay. So guys, those who have forgot to like, please do like as well as subscribe the channel because you will be getting a lots of surprises. Okay. Yes, yes. So we will be getting the flux through this side as well as for this side. If you're finding it, what will happen? This is coming as again E into area. E will be again 200, okay, and pi into what is coming as R? What is coming as R? It is coming as 5 into 10 to the power minus 2 the whole square. The next step is you just need to add these two values. Okay, so you will be getting the answer for this question. Now, next question is, what is the net charge present inside the cylinder? How we will be finding the charge? Now we got the flux. If we are finding the total flux, we got the flux value. Once we got the flux, we know which is equal to Q by epsilon naught. So if we are just multiplying this to phi into epsilon naught, you will be getting the charge as well. Hope you guys got it. Okay. Now let us go for the next question. What is in the next question? A uniformly charged large plane sheet has a charge density sigma. Find the electric field at a point A, okay, which is 50 centimeter away from the surface. Plane sheet. What is the field equation? What is the field equation? Sigma by 2 epsilon naught. We have already done it. Sigma is already given. What is sigma? Sigma is nothing but 1 by 18 pi into 10 to the power minus 15. Now it is the turn for 2 epsilon naught. Okay. So 2 epsilon naught, either you can just substitute 2 into 8.85 into 10 to the power minus 12. Otherwise, I will give you a very simple format of this one. Then you can just make the calculation a little bit easier. We know 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. Okay. So now you can just see that if I just wanted to find 2, I'm just keeping 2 here and I'm just taking 9 into 10 to the power 9 that side. So what I have after that? 2 epsilon naught. Right. I'm taking 9 into 10 to the power 9 this side and I'm taking 2 and 1 pi also. So after I'll be having 2 epsilon naught. So once you get it, you can just substitute the value over here. Okay. 18 pi into 2 epsilon naught will be coming as 1 by 18 pi into 10 to the power 9. So you can just cancel it out and you can find it. Okay. Not every day, no, every alternative days you will be having the physics class. Monistry, right? Yes, of course. Okay. Yeah. Okay, those who are coming new, do like the video, and yeddachu doubt irunda, you can ask me in the chat box. Okay. Understood? And subscribe the channel for more updates. So now we got the electric field. So we can just find it like this. 18 pi will be get cancelled and you will be getting this as 10 to the power minus 6. Okay. Minus 6 is going to be the electric field, Newton per Coulomb. Now we are moving to the next question. Next question na, consider straight line with 3 points. P irukku, Q irukku, R irukku, placed 50 centimeter away on the right side of the sheet. At which of these points does the magnitude of electric field due to sheet remain the same as that of A? P, Q, R both will be having the same electric field as A. Why? Because electric field வந்து depend பண்ற ஒரே ஒரு விஷயம்னா distance தான். Okay. Okay, the distance is very important. So in the case the distance வந்து same. And in the sheet, in the infinite sheet க்கு வந்து advantage na, it will be producing uniform electric field. So distance is not, you don't have to bother it. And electric field one, the equation one, the sigma by 2 epsilon naught. Epsilon naught is a constant, 2 is also. Then sigma. So sigma is the only one. So here that is also same. So 50 centimeter away or even 100 centimeter away, it will be having the same electric field. Okay. So the answer one, the P, Q, R, ella, it's going to be the same electric field as A. Now we are coming to the next segment. 2 small identical conducting spheres carry. I think we have done this question. We already done this question. So we are going for the next question. A square surface of side L meters is in the plane of paper. E is limited only to the lower half of this square surface as shown in the figure. Electric field E is in volt per meter. The electric flux associated with the surface. Can you find it? Very simple question. If you're just thinking, just the Gauss's law part, you can answer it in a very, 1 second la ungalku answer kadakka mudiyum. So electric field and area vector. So it is depending upon two factors, electric field, area vector, and the angle between them. So now think, what is the angle between area vector and the field vector? Tell me, what is going to be the angle between area vector and field vector in this case? Tell me, what is going to be the angle? Very simple, think and tell me. What is going to be the angle? It's going to be 90 degree, right? Because the plane, this is the plane, so it will be, the area vector will be perpendicular. Field is in this direction, so the angle will be 90 degree. If the angle will be 90 degree, what is going to be the flux? Flux enna aga pore? It is going to be 0. The answer was 0. Next one, the square sheet irukku. Side A lying parallel to xy plane. Okay, lying parallel to xy plane. So the area vector will be towards z axis. At z is equal to A, electric field in the region is Vz square. Okay, Ez square k cap. Okay, and what is the direction of area vector? Area vector is also k cap because the plane is in the xy plane and the area vector will be perpendicular. So we will be getting this. Now the electric flux produced. So how we will be finding it? How we will be finding it? We know flux is equal to E dot A, and in this case theta is equal to 0 degree. So flux வந்து E A, E, what is E? Z square, okay, and area வந்து, the side is A, it is square, so area வந்து A square, and in the case la வந்து Z oda value A. So I'm substituting that A square, so the answer வந்து CA to the power 4 K cap. Okay, so direction la the flux ku vandu scalar quantity, so adukku what is a direction idu illa, so the answer vandu C A raised to 4, hence option 1 is the answer. Okay, again and again you have to like the video, subscribe, and for February 6th we have a lots of surprises, so you should get the updates. Okay, so let us see. Now we are going for the another question. Which statement is true for Gauss's law? You can give me the answer. A, B, C, D. Which one is the right answer? All charges, whether inside or outside Gaussian surface, contribute to the electric flux. Is it true? Is it true? No. False. Why? The charges inside the Gaussian surface only will contribute for the flux. Next one, the electric flux depends upon the geometry. As I said, no. We are taking some geometry because we know the area directly. Random shape, what will happen? What will happen? We can't just find the area simply. Gauss's theorem can be applied for non-uniform electric field. That is the major application. So, this one the true. Electric field over a Gaussian surface remains continuous and uniform at every point. No, that is also wrong. Hence, the option is C. Very, very, very good, Anish. Okay. So now we are going for the next question. What's the question? If the net electric flux through a closed surface is 0, then we can infer that. What you will understand? If I'm saying the flux is 0, what are the possibilities in the list? What are the possibilities? Tell me. Either the angle between them is 90 degree, area vector or field. Otherwise, the charge must be 0. There is no other option. Hence, I can say the first option, no net charges enclosed inside the surface. Okay, so these are the things we have in this chapter. And as I mentioned, the important derivations already na in the class la mention pannirken. So, on the derivations neenga focus pannanum, and high weightage chapter da. At least 7-8 marks in the chapter. First chapter multiple times it is asked. So, in the chapter 1, the board romba important da. derivations, don't miss the derivations. Also in the chapter la vandu konjam equations da irukku. You have to read, you have to write the formulas. Otherwise during the exam time, after studying the whole chapters, you will forget each and everything. Okay, so adanal da solre, all the time whenever you are studying the formula, you should write. Okay, as well as just practice the numericals. We also going for some lectures for PYQs and numericals, especially during the exam time. So you should complete the theory part, and I will cover all high weightage chapters in this evening classes. So don't worry, we will cover, but I want your full attention in the class. Okay guys, so we will meet in the next class. Okay, so till then, bye bye, study well, take the notes, and make sure you will be doing everything. Okay, so study the whole chapter. In the next, when we meet again, you should tell me, ma'am, we have done electric charges and fields, done and dusted, we don't need to do anything. Okay, and PYQs and numericals we can do it separately. Okay guys, so all the very best. Don't take rest. Okay, this is the only time we have. We should work hard. So all the very best. Thank you all for supporting, giving the answers on time. So next day also I'm expecting you people will be coming on time, and try to come. Yes, Danamo. Okay, so yes, Damodaran Yoga. Okay, yeah. Okay. Bye. See you. Second chapter, I will do a video. I'll record the video. In the next class, we will be going for the current electricity. That is another high weightage chapter. I will do the recorded video and I will upload. So you can just watch it. Okay? Will be fine, right? Next class, the current electricity. And next third class, the ray optics. Fourth class, the semiconductors, nuclei, dual nature. So these are all the high weightage chapters. Nama adha focus panna pora. So adukku tomorrow, of course, we can try. Okay, don't worry, we will do it. See you guys. So next class I think it is on Saturday. Saturday 12 p.m. So everyone should join on time. Okay, and edachu concern irunda in the comment box la message, you can just put a comment. I will give the solution. Okay, see you, bye bye.